Good morning. We will start soon. Chris is sick, so we will only have 2 presentations this morning. First presentation is Mike Solomon, an SDOM approach to web audio. And please start when you want.
Great, thanks. So hi, welcome. Somebody pointed out to me that SDOM looks like Sodom from Sodom and Gomorrah. So I realized I didn't name it, but on the bus people are having biblical thoughts, but that's okay, of course. But it's called SDOM, so not to be confused with the city from Genesis. So an SDOM approach to web audio that I'll be presenting today. So a bit about me, just to kind of contextualize where I'm coming from. So 2011 to 2017, I worked at the Earcom and Graham on various digital audio roles. I started my own company in 2017 to work on ML DSP-based audio, and we wound up exiting to a reputable group of seasoned professionals with the company. And then on the heels of that resounding success, I started a company with the same founders, backed by the same investors. So that's me. And then where I landed. So we're building a demo social rhythm game app now with my company called Joyride FM. If you're bored during the presentation, there's many ways to spend your time, but one is going to that website and playing the game. And then we've open sourced our stack on GitHub, which includes the following 4 libraries. So one's called Hyrule, functional reactive programming library, Deku, yet another web UI library a la React, Rito, a set of 3JS bindings, and what I'm going to talk about today used to be called WAGs, but now it's called Ocarina, a web audio library. For those of you that are Zelda fans, you'll realize that all the names come from that. But of course, like everybody in the room, I try to do word salad. So for Rito, I have reentrant, idempotent, temporal, oculars, and there you go. So if anybody wants to come up with a better name for these libraries, then feel free also to play at that during the presentation. So what I'd like to start with is sort of the why, what, and how of what's going on. So why? We're building social rhythm games in the browser, right? So this is kind of an example of it. So this is just the tutorial, shows how to play. It's a phone-based game, so you're supposed to use your thumb to press and stuff. So I'll click. I was on time because I went to a conservatory, so I have that ability. So that wasn't on time, but that's fine. So social rhythm games, there's pre-recorded tracks, there's live tracks, things that come in, and it has to be at 60 FPS, which this is, and of course it's in the browser happening right there. So let's exit the tutorial. So that's what we're building. Why? We're building a social rhythm game. So this is kind of motivating the framework for it. So perhaps you and I know several of you are building games engines or building audio SDKs. So if that why sounds like your why, then hopefully this will be a kind of an interesting presentation for you. Rhythm games, what do they need? They need to be reactive. As you saw, I'm clicking on tiles all the time. They need to have a tight rendering loop, 60 frames per second. And we saw that with Wise that Philippe presented as well. Like it just has to. It can't lag, otherwise people will bounce from your game. And in this particular case, it needs dynamic signal processing chains, meaning that it's not just that we're triggering one sound here and one sound there, but we can trigger entire effects which take the whole entire audio graph, for example, into a low pass filter if a certain event happens in the game. So instead of having this one-off logic, it kind of has to, or at least we've decided it has to have a graph-based logic. So the what? So what are we going to learn about today? So I'm building rhythm games, and I'm using an SDOM approach to web audio. SDOM is short for static DOM, in contrast to VDOM or virtual DOM. And you might have heard VDOM if you work with React or Angular. It's a technique. So my claim is that SDOM as a technique is going to allow me and perhaps allow you to realize engines that kind of run at the speed. And what I'd like to teach you today are the basics of how to implement that sort of approach and show a couple of benchmarks. And then how I'm going to do it is with PureScript Ocarina, an SDOM-inspired web audio library that myself and others wrote. So to recap, why to create reactive immersive games, what you're going to learn is the SDOM approach, and how is through PureScript Ocarina. So by the end, I hope that you'll understand what it is, what forces led to it, its major design choices, and its limitations. So I'm going to do a bit of history. And just so you'll be able to conversantly kind of understand the trade-offs and decide, is this for me or not? You'll know when to reach for these patterns. So like you're sitting there in your office, you're writing code, and like you kind of after I'm long gone and we've parted ways, like when is this little chunk of information perhaps useful for you, and when can you use it during like 15 minutes of a coding experience to maybe speed stuff up or make your app a little bit more stable. And then I hope that you'll take away a little bit of the theory behind it too, because it uses functional programming. So those are my hopes. At the end, maybe I'll ask you if I achieved those 3 things, and I hope that you answer with a resounding yes. So goal 1, what is SDOM. So before SDOM, there was VDOM, so virtual DOM, introduced by Angular and React. So what is VDOM? In a VDOM, an app is a function from a data model to a DOM. So you have a data model that comes in, and a DOM, or a virtual representation of a DOM, comes out. And when the data model changes, we diff the new virtual DOM against the old virtual DOM, just like what Git diffs the new repo against the old repo, comes up with a patch, and then we apply the patch to the real DOM. So essentially, by diffing, we see what's changed, and we apply that as a patch. And that's ubiquitous. That exists in React, that exists in Angular. And if you use Tone.js under the hood, that's how the engine works as well. And I'll have some benchmarks with Tone on it. So you could say that Tone is the VDOM, but V audio so audio object model, if that exists. DOM, by the way, stands for document object model, and it's kind of what's involved in the layout of documents. So there was a seminal paper in 2018, or at least seminal for me, called "You Might Not Need the Virtual DOM," which was heresy because it was the height of that. So of course, this person comes in and decides to throw out the baby with the bathwater and says, denotationally speaking, the virtual DOM is very appealing, but operationally, it is a heavyweight solution for many problems. This is important. Every time, and think about games, right? They can't be heavyweight. So this interests me right away. Every time we modify our application state and return our render function, we allocate a new tree of virtual DOM components and perform a tree diff in order to discover what must change in the actual DOM. For most applications, this seems to be overkill. We can optimize the diff algorithm in various ways, but ultimately the diffing is essentially unnecessary. And this is a little bit like what Paul said yesterday, that kind of the best way to optimize something is not doing it at all. So even if you have this super optimized diffing algorithm, you still have a diffing algorithm, and it's going to take time. But in simple changes, you know precisely what needs to be updated. We simply need a way to make this obvious in the code. And that way is what he invented, SDOM. So the design principles. The nodes in a graph never change. And that's why it's called static DOM. Asterisk, except for when they do. And I'll get to when that happens. But imagine that it's static. So you create a bunch of nodes and they just live, meaning that like you have 10,000 sine wave oscillators, and that's it. You allocate them and you never take them away, and they're just there in your graph. And you have 20 gain nodes, and you just allocate it. So it's not, stuff's not coming in and out on the fly like the piece starts, and you just allocate a whole bunch of stuff. So that's the first thing. Next, nodes listen to event streams that modulate properties. So you have an event stream that's firing like a frequency event. And because it knows that the node was allocated, it doesn't need to do it if node exists, then otherwise. It doesn't need to look at a diff to know if the node was destroyed, because it's not going to be destroyed. So it's static. So you just have event streams that know that a node is going to be present and then modulate it. So that makes it fast. And because the node is static, event streams can cache a reference to the node. So that means no more calling like document get element by ID. Now, this is the DOM. So audio, we're not calling document get element by ID, but in the DOM, you can cache it once and fire and forget to the node, and you know it's always going to be there because it's never torn down because it's static. So that's the methodology. That's the important bit to take away. Hello, SDOM. So this is SDOM code in PureScript. That's my language of choice. This is it working in my browser. I'm sure that you would have believed me that it works otherwise. But so the way that it works, it looks very much like, so if your PureScript syntax is foreign to a lot of people, and I'm sorry about that. But here, there is a static div, a static button. So this never flies in and out. There's no diffing to say, did this button disappear or did this div disappear? It's all there. It stays. And then what changes, you see that stuff's updating. And all that's updating is an event stream in this text. And this event stream grabs a reference to the text. And every time the text needs to be updated, it doesn't diff the DOM. It just hydrates its reference with the new value. So by making that architecture and that design decision, it winds up being blazingly fast. And for this little web application, its speed would not be an issue in any language. But when it scales up to something like the game that I showed you, the speed is kind of make or break for the quality. So again, that is how an SDOM app is set up. Hello, SDOM audio. So a bit the same. This is kind of an involved example, but same thing. You have a delay that has a gain. This is a fixed point operator. So in functional programming, a fixed point is a function that takes itself and returns itself. It's called a Y Combinator. So a fixed point in audio is a loop, is a feedback loop essentially. So you could have fixed points in a graph. Kind of anything from graph theory that can be in a graph is representable in the SDOM model. And fixed points, of course, are important to have reverb. So this is SDOM in my browser. This is me modulating in real time. So I'll do it again because it might not hear. So here there's I think 20 simultaneous feedback loops that are all being rendered in real time on a canvas. and it reacts immediately to the slider, meaning the slider is changing the length of 20 delay lines simultaneously, and it's doing it with kind of no droppage and no issues in the. You hear no clicks, no bleeps, no bloops in there at all, in spite of the fact that it's an extremely dense. Over 100 node web audio graph, because all that's happening is that whenever I drag the slider, it is sending event. It caches the audio nodes. It knows exactly which audio nodes it modulates, and it doesn't need to kind of look through a tree. So that speeds up stuff quite a lot. So let's do a benchmark really quick. I'm going to open and inspect it. This is in the paper as well if you're interested. Of course, benchmarks are awful because they're designed by the person that creates them to make the other guy look bad. I'm guilty of that as well. But so that being said, also benchmarks use awful sound. So like I decided to one-up them and use a really awful sound. So I'm going to turn it on. It's quite unappealing. Sounds like a fire alarm. So this is a node just being like allocated, torn down, allocated, torn down. But they're all there. It's just that they're like being used and then not used. So this is SDOM. I'll stop it. And if we look at the profiler, I'm not gonna. So I told Paul yesterday that I feel a little guilty showing a profiler in a sort of casual way and not digging a deep way. But I would just like you to look at the geometry and see that it's not that dense. Why is it not that dense? Because every time that a function is being called to turn on or off an oscillator, the call stack is really short. It's just saying call that function. As a result, this library that we're using occupies this little tiny sliver, right? It's almost none of the loop. The same thing implemented in Tone.js, and this is the code, by the way, is kind of short and sweet. I tried to make it idiomatic. I made this idiomatically Tone.js. Same example, same exact example, a little softer, but otherwise the same. Just following their documentation, like no more, no less, same as if you follow mine. We're going to profile it, and hopefully mine will be faster. Otherwise, I would be super embarrassed, but I think it will. Turn it off. And it is. So this is at 690. The other one was at 70. So it's about same number of seconds, about 10 seconds. I forget exactly what, but you can even see visually it's roughly 5x more. And the important bit is the density of the trace. So what is happening in the density of this stack trace? If you zoom in, and I talk about this in my paper, but a lot of these algorithms, for example, for each tick between, is the VDOM algorithm in Tone.js performing the diff and seeing what sign node is there and what sign node is not there. And if it's not there, I'll tear it down. So you have this VDOM approach in Tone.js that slows it down quite a lot for these types of things. Of course, even this is quite good performance, meaning that it occupied like 10% of the rendering loop, but the SDOM approach occupies 1. And when you're doing like when every millisecond, nanosecond counts, it can make or break your application. So that's that. So SDOM's advantages: build a graph declaratively, like in Fausto JSX. It's fast thanks to upfront allocations, and each reactive component is very efficient. So when and how do I use this? You practitioners, you're not writing in PureScript. Most of you, if not all of you. So case 1 is for fixed graphs. So for example, if you have like, this is like a fixed graph, doesn't change over time, like a good time to use it. You can see that's just like an audio graph, and the nodes are not coming in and out. So another one is if there are bounded outcomes, and by that I mean that in SDOM, events don't need to inject just control values. Events can inject sub-DOMs. It's kind of like you could put an iframe in your DOM, right? And then you have a whole DOM. So the SDOM, that's how you cheat. That's how it's not static, because into the static DOM, you could inject other static DOMs. It's sort of the dynamic backdoor, just like into a web page, you can inject an iframe. So here, it's a little bit loud, but I'll turn this on, and it's injecting dynamically thousands of sub-DOMs to create a wind chime. Each chime that you hear is its own buffer. So I've already, just by doing this, allocated thousands of them. No clicks, no glitches, no bloops, no bleeps, like now well over 1,000 dynamic nodes. So and it works, and the code is kind of up here for how that's done. If you're interested, it's on the documentation. So if you're working with bounded outcomes, it could be a good choice as well. Its limitations is that the dynamism has a bit more difficult mental model, and it's not very JavaScripty. So what I'd like to finish with, I think I have 5 minutes left, of which some need to be for questions, is a little bit of theory, because I think the theory behind SDOM is quite beautiful. So the type, I've been talking about events, right? The DOM receives events, but like what is an event? Like okay, I'm going to stop throwing around that word and kind of put some meat on the bone. So the type of an event in PureScript, you see what is up there. It's a little hard to read types in TypeScript, let alone PureScript, a language that most of you haven't seen before, but I'd like to just tell the story of what it's saying. So it's saying, if you give me a function, that's the first argument to the type. So the first argument to the type is a function. The type is a function that takes a function. If you give me a function that I could call every time a value comes in, I will return something to you, effect unit. So effect is a thunk in PureScript. The outer effect, you thunk to turn on the stream, and the inner effect, you thunk to turn it off. So it's like a faucet, on, off. So if you give me a callback that I can call with values, I will return you something that can turn on and turn off the callback. So types in TypeScript or in any language are like contracts, and this is the SDOM contract. So the interesting thing about this, it's also called continuation passing style, and functional reactive programming is another term for it, is that it unlocks really important patterns. So for those of you that have worked with Haskell or Scala before, you know what a functor is. And a functor, you could do something map. I think that a lot of you have used map before with arrays or map reduce. You could define a map function for event. That's the definition of it. And what that means is that you can map over an event, meaning map over every value in a stream, just like you map over an array or map over a maybe value. That's pretty cool, because that means that you can use these functional programming patterns out of the box with this model. There's a bit more theory too, but I'm running out of time. So I just want to kind of give you a glimpse of what's going on. So to summarize, SDOM is an alternative way of modeling a DOM that can be applied to audio, as you saw here, that allows you to create very fast applications in cases where speed matters. So that's me. That's what I'm up to these days in building a game. I hope that those of you that if you were looking at your phone, you were playing it. If not, it's at joyride.fm, the little demo, and I'm happy to take any questions. Thank you.
Thank you very much. Do we have any questions from the audience? Yeah, I was wondering if you also apply this approach to 3JS, wrapping 3JS graphs, and how that works out.
So the PureScript Redo library that we have wraps 3JS, and we do exactly that. There's some interesting differences though. One being that 3JS is not hierarchical; it's a scene. So there's occlusion, things that cover other things. But where SDOM could be really useful is in the listeners. So for example, raycasting. SDOM speeds up raycasting radically, and raycasting is used to click the tiles. And when you have like many tiles being clicked simultaneously, it really speeds stuff up, we found.
Hi, thanks for the talk. I didn't know about that approach, so thank you for that.
Yeah.
So you mentioned, you talked a lot about the way you approach SDOM for web audio nodes, but are you also using it for the visuals of your game, like using DOM?
Yeah, so the visuals, the 3D renderings in 3JS, which I just mentioned, but also the DOM, like kind of the welcome menu and everything is running that way. So for example, in the game, there's like little messages that popped up that said like nice or bad or whatever. And those little messages are not rendered with the 3D rendering engine because it takes way too long to download the fonts. We just use a div with that. And that div responds to the same exact event that my audio responds to. So it kind of creates this nice synergy. If kind of multiple libraries buy into this model, there's a compounding effect. Yeah.
Okay, and maybe a follow-up question. So clearly you were concerned about performance when you started this project, and you knew you had to have something optimized, and you were already aware of the dangers of using virtual DOM also for audio.
Yeah.
So with those two things in mind, why did you decide to go with this route and not decide to go the way of, for example, doing just one audio worklet node with an optimized DSP running inside?
I think so. It's a really good question. For me, the act of using events, like mapping over events, like I showed at the end, you can map over it like an array. You could also compose two event streams together so that you could filter event streams. There's lots of things that you could do with an event just because of the type that it is and the type class that it implements in Haskell and in PureScript. So for me, the choice to do it was one of knowing that by creating something that obeyed these laws with the type system, it would allow me to compose things together kind of in this process of almost creative discovery, if that makes sense. Whereas I'm not saying that you can't do that with a single web audio node. You could also be creative through that. But I feel that a lot of people that are into functional programming, which I very much am, see using the type system as a kind of a way to surf creativity, and kind of it will lead you to places that you might not have thought you go. So I wanted to afford myself opportunity, and that's what happened. Like I've been able to make kind of choices that have surprised me, and inversely see people that make choices that surprise me because it adheres to that type system.
Okay, thank you.
Yeah.
Yeah, I would also be curious, how does this relate to frameworks like Svelte? So that's like a different approach again. I think it's not static, but like it keeps references to every node's and render time. So
yeah, so Svelte, it's there's another called Solid.js, and they occupy a similar space. So both of them have dedicated compilers, and I would say that those frameworks are industrial, meaning they're for people that like don't mess around, essentially. So like you have one goal, and it's to do all the things that an industrial product needs, which includes onboarding junior developers. So one really nice thing about Svelte is it looks like HTML. So you could hire somebody that just did a boot camp and came out, and they could be really productive really quick. So that's industrial, and there's many other things that are optimizing for that. It sort of, you lose a bit of the richness of the type system, but if, like, I say lose not like in a pejorative way, it's just that's the trade-off, right? I wanted to have that. My co-founders wanted to have that because we enjoy it. So I think Svelte is great in an industrial context, and any dedicated compiler is always going to be better at what it does, or almost always, than a general purpose tool. But I do think that ours has is compelling enough performance to make it worth working in this general purpose language that's pure script.
Very good.
Okay.
Yep. Thanks very much.
Thank you.
And yeah, the next talk will be online. So this is going to be a video, and the presenter will be online after on Zoom for questions.
So yes, let me show the video.
Hello, Web Audio Conference.
Sorry. Are you ready? You can go.
Hello, Web Audio Conference. I'm Peter, and I'm sorry for not being able to be in person with you, but still very happy to be able to give this talk. So thank you for having me. And I will talk about WebAssembly Music, which is a project I've been playing with a few years. It's inspired by executable music from the demo scene, where it's about having all the music inside tiny executable files, typically less than 30 kilobytes, and containing all the logic and for rendering the instruments, the sounds, and also the music itself. So I've translated this concept to WebAssembly so that everything runs in the browser. And I'm using Web Audio only for the audio output, because everything is going on inside the WebAssembly binary. Everything that comes to effects, the synthesis of the sounds in real time, and the music. So I have a live coding environment here, and on the left side you can see that there is JavaScript for all the nodes and the MIDI data. So it's JavaScript generating that, and on the right side it's the code for the sound synthesis. So all effects and all the instruments are coded in here, and I can code live and have it compiled on the fly, because this is a feature of AssemblyScript, which runs perfectly in the browser. So let's hear what it sounds like. So. So that's a song, and we can also just play the instruments here. So we have the pad, and we have the bass, for example, and some organ. So all of these instruments are defined in here, and I'll show you later how to code and update on the fly. But an interesting feature here is the possibility to be able to export to a WAV file. That's one thing, but also to a WebAssembly binary. So then you get that tiny WebAssembly binary that contains all the code and all the media data that you have set up here. And you can use that for creating these executable files, either a native executable or an HTML file that can play this. So let's move on. This is my setup in the browser for this live coding environment. It's using Audio Worklet for low latency, for real-time performance, and this Audio Worklet processor contains the WebAssembly synth, which is doing all the work. And the web MIDI is connected too, so the MIDI messages are sent via the message port. And let me show you an example of this tiny WebAssembly binary inside an HTML page. So here is an HTML page. Let's just look at it. It's one single file that contains everything. So inside here, you can see that the WebAssembly binary is contained in base64 format. And we are calling that WebAssembly binary from here. Just play events, media events, fill the sample buffers, and we are creating buffer source nodes in this case, and just sending it to the web audio outputs. And then it sounds like this. So that's it. And to create a simple sequence, well, that's the JavaScript code, and you can see here we are creating a track, and we are setting up the MIDI nodes here in sequence. So we can just copy that into an empty environment that I have here. And we also need some synthesizer code, so let me just move on to that, which is here. So I'll copy now this here, and what you see here is a very simple instrument. It's just a sine function. We are translating the note frequency to the angle parameter into the sine function, and we are adding that sample onto the channel output, and that's it, more or less. So let's go in here and just paste it. And now we can also try it, and we have the sequencer enabled, so we can just start playing. And let me also alter the sequence while we are playing. So change some notes like that. So you can hear that, and let's also have more steps. So. And we can also just play the instruments by turning off the sequencer. We can play it from the MIDI keyboard. And let's also just demonstrate altering the instrument itself. So let's add another sine wave to it, just like this. So let's say 0.7. That will give another little higher frequency. So pretty easy to just experiment with different setup on the fly, compiles on the fly. Let's move on. So the next is what I've been playing with now the recent year. It's physical modeling, very complex topic. I have still a lot to learn. I'm trying to catch up of a lot of things, math I should have learned in my 20s, but you know, It's never too late to learn stuff. I've read a lot on the notes of Julius O. Smith. He's the expert on this, and Pierre Cusa has some really nice, simple tutorial to get you started. And I think there is no better interface here than Live Coding Synth for experimenting. The concept is just a burst of noise. Well, very simple said, but and you kind of make sure that noise has some envelope and filters to it, and then you put it into a feedback loop where the delay is delay buffer size is according to the note frequency, and you also filter that, so it goes into a loop here, and that starts to resonate, and then it generates a tone, and very kind of gives you the possibility to create quite interesting instruments. So let's hear it. Let's see it first, the code here. What's really going on here is inside this processing. So it's what I just showed you in the diagram, where you have the exciter signal, the noise, and you just feed that into the delay line here. You process it with a filter, and you kind of add it also to the existing signal. So, and here, up here, you just set it up based on the incoming note frequency, the incoming velocity, and yeah, and let's just copy that and add it here to our synth code. And we also need to, now that we have this waveguide, this is not a full instrument, so we have to connect it to this first instrument that we set up. So just let us set it up, and the first parameter is the attack, and we need to have some decay and some filter for the feedback, and finally the feedback. So let's set it like that. And now we actually want the sample to be taken from the waveguide. So let's call the process method. Like that. And also let's here start the waveguide. So this waveguide and start, and the input is the note frequency of the note, and let's now just set a fixed filter value, not involve the velocity here. And well, that should really be it. We'll just see what compile errors we get. And now we are missing some imports, so let's add that on top here. Just add it to, there's no complaints left. Like that. Filter type we need, and we need the filter coefficient for the biquads. Noise is very important for generating the signal. So let's try and play it and see. So okay, we can hear that something is going on here. So then we can start also just playing a bit with the parameters. So let's have a look and change the filter, for example. So also this filter here on the feedback loop. So it starts to get a bit more interesting. So you can hear it kind of resembles a string sound now. Let's just remove the feedback, and then you can hear it's just a burst of noise. So, like that. And also let's try with negative feedback, which is very interesting because then you get more flute characteristics here. So, okay, let me go in and show you some more advanced. Just move to the string instruments, and here I use my pre-setup in my assembly script library that I've got here. It's all this waveguide code is ready, so you don't really have to set it up every time. So here I have two waveguides to create a nice stereo effect, and just by setting the parameters for it, we will get a more string sound. So I'll copy that into the environment here. Then we need a new channel for that instrument. Let me set up that. And let's also allow like 10 voices simultaneously. We miss an import, so let's add that since I'm not using that simple waveguide now. And also let's just add that string instrument so that it shows up here in the dropdown. And let me play. So now it's starting to sound more interesting. So I have a lot of instruments here, so let's just check it out. For example, here is a piano. And we got the string already here, but the drums is also possible to create using this concept. So it's only the same concept with and bass is kind of cool. And flute is one of my favorites. And finally, let's check out the choir. So as you can hear, there are endless possibilities here, really. The piano is kind of the complex thing. It's very difficult. I haven't got it right yet. It's still struggling with it, but I'm trying a lot of things and reading a lot and trying the best I can here. But some stuff it's to add here is the dispersion to get kind of a stiff string, or also the possibility to create a bit out of tune, which is important with the piano, and also the soundboard, which is kind of enhancing all this sound from the string that is mixed together. So this is actually simplified diagram of how it really is. Let's look into the code. We have also here for the exciter some delays, because we want the strike to the string to happen multiple times in delay. And we also have the dispersion I just mentioned. We have here a lot of cascaded all-pass filters, and finally also the piano channel, which is the soundboard. So all the piano notes go in here and are mixed and just added in multiple all-pass filters again. So let's copy that, and let's just create yet another instrument. And what we need now is also an additional channel. So and this time we need to use the piano channel, because we need that soundboard and the piano. And now we see that we missed some imports in the top again. So let's just add it from the library. The delay line also is important. So there we are. Let's try it. Let's choose. Oh, we also need to add the piano here. Like that. Piano. And let's just hear it. Select it too. We can also just add some reverb to it. So then I've actually implemented in this MIDI synth controller 91, which is the typical for a reverb. Let's just set it to like 50. And let's just also see what happens if we remove this all passes for the piano channel. Then it sounds like this. So just need to see. Okay, so yeah, quite annoying. so we need that, and also let's play a bit with dispersion, which is quite interesting. So here it's 0.15. Let's turn it up to 0.3. So it becomes more out-of-tune, and that's also an interesting feature of some pianos. Yeah, so again, a lot of things to play with here. And finally, the full band. This is a song with a lot of instruments. Let's just hear how it sounds all together. So I'll skip a bit into the song. So that's all from me. So thank you for attending. Thanks for watching, and I hope you enjoyed it. So see you later. Bye.
So we'll now have time for some questions.
Yeah, but Peter will be online.
Yeah, Peter will just appear on the screen in a moment. Ah, hello Peter.
Il n'est pas allumé tout le temps.
Hello. Can you hear me? Well, we can't hear you. 1 second.
Okay. Yeah.
It works now. Perfect.
It works now. Okay. Bonjour tout le monde.
Bonjour, Peter. Does anybody in the audience have a question for Peter? Attila or Michel? Yeah.
Yeah. So I was just wondering how big, like the binaries you showed were really tiny, 30 kilobyte, I think. So I'm wondering if, like, how would you handle samples or any kind of assets files that you would ship with the song? You know, usual trackers, I think, or usual, composition. If you're not only dealing with synthesis.
Yeah, so the question is, how do I handle samples if there are more than just synthesis? And most of the songs I've done until now is purely synthesized, so there haven't been any samples at all. So everything is possible to ship inside these 30 kilobyte binaries. But I've also created a function inside this live coding environment where you can add audio. You can actually add a WAV file and you reference it from a URL, and it will just load it into memory and send it through this WebAssembly binary. So you can use all these effects that you have in the WebAssembly binary and yeah, you do whatever you want with it. So you can play it and you can mix it and you can enhance it. But
and then in case of shipping the total music, of course you have to export it to a WAV file. It's probably too big for a single binary file, but yeah. So,
Yeah, that answers it. Thank you. It's really cool.
okay. So, anything else? One question.
Hi, Peter, it's Michel. So we already exchanged with Peter. I was wondering why he did that. So why did you reinvent web audio or whatever? And maybe you can explain your background from the demo scene, and that the fact that you wanted to export very tiny pieces of code that could be embedded in a video game or in any kind of application. Could you speak about your background and why you did that?
Yes, so about my background. I started in the demo scene on the Commodore Amiga in 88, I think, something like that. I started programming in 1985. And back then it was all about having to make demos. A demo is typically graphics and music and some content which should fit on a floppy disk. And the floppy disk at that time, they could room like, I think it was like 180 kilobytes, which is actually more than we use now for these WebAssembly binaries. But this has been going on in the demo scene all the time to be able to create these presentations and music demos as tiny as possible. And today you see them down to 4 kilobytes and quite still impressive. I've even seen things in 256 bytes, which is very impressive too. But I just wanted to take that concept also to the browser. And when WebAssembly came along, I saw that possibility that you could actually export music content. You could fit it into this single WebAssembly binary. Like they also do the demo scene today. If you go to these demo parties, you have these competitions about executable file less than 32 kilobytes, which should room music. And it sounds like real stuff, like impressive instruments and all this. So I just want to take that as web browser. And that's also why I'm not using web audio for, well, I'm only using web audio for the audio outputs and not for actually assembling the sounds, because all that goes on into inside the WebAssembly binary. So.
Yes, thanks, Peter. Thanks, Peter. And may I add something? Is that I tried the software and the sound of the instruments is much better than what we heard with the video. It doesn't doesn't reproduces faithfully the sound, and the instrument sounds really good. And yeah.
Anybody else?
Yeah, I think that's important to say that the video is kind of degraded. So to get that full experience, you really need to hear it from the web browser itself and play with it. And also even when shipping the music as WebAssembly binaries, you get a full quality compared to an MP3 file, which is not really the same. So that's also an aspect of it, that you can ship it with full quality.
Hi, thanks for the demo. It was really nice. I was just wondering, is that a private experiment, or do you intend to? Do you have a GitHub repo, or do you want to make this available and with contributors, or is that just an experiment?
It is available on GitHub. It is a GitHub repository. It's github.com/Peter Samuelson/JavaScript music, because it started as JavaScript music and evolved to WebAssembly music. So you can explore it a bit there. Well, for me, it's been a private thing. I made it for creating music myself, but still it's open for everyone to to fork and even contribute if they want. I think for me, my main focus is to just create music with it and create demos and yeah. So but you find everything there.
Okay, thanks.
Any other question? Okay, thank you very much.
Peter, we see the weather where you are located, and it's really a shame that you are not here. Here, it's sunny, it's hot, the sky is blue. So it's why are you located in Saint-Jean-de-Luz right now? I don't understand. Yeah, you made a big mistake. Trust me. Next time, listen to me. I just had, let me just add that Peter has a very well documented video blog, or I don't know, on his YouTube channel. He posts videos regularly about what he's doing and so on. And we talked together for a long time. So I don't know if he agrees to talk with any of you for hours, but he's somebody very passionate. Thanks a lot, Peter. C'est fini maintenant, c'est pas dans le programme. Okay. No, I think it's your turn, Paul. Yeah, Paul will tell us about what to expect about the Web Audio API, what the Web Audio Working Group has been doing, and so on. And after that, we will conclude about a discussion, an open discussion about the future of WAC, what is going to be next, and so on. And for this discussion, maybe the old WAC organizers and WAC regular attendees could also join me on stage. And of course, we will discuss with the community about what we do next year and so on, and how we can keep organizing this conference, on what forms and so on. So Paul,
Juste HDMI, ouais. Ouais, pas de son. Ouais. Ouais, un micro là. Ouais, voilà. J'ai le micro sans fil. Ouais.
I'm just here for support.
Hello again. So yeah, it's me again. I changed hats. I'm not a Mozilla person anymore. I'm a W3C Audio Working Group representative now. As usual, I'm going to do little updates of what's been going on this year. Well, actually a bit more because of the pandemic, etc. What's been going on in the Web Audio API? Talk is called Web Audio API 2.0. What's new? Well, spoiler alert. There is no 2.0, but I will explain that in a few slides. So now a bit of legalese. The Audio Working Group is a W3C working group. It's been rechartered until June 2024. What does it mean? It does mean that we can continue working, essentially. So we have, I don't actually have the internet, but one sec. I need to open some links. So what does it mean? Yeah, it means so we need to have a charter in a working group to kind of scope the work that we're doing with a number of different companies. So it scopes what we do. It lasts 2 years usually. It's a long document that really explains what is in scope, which is also interesting. For example, what is not in scope is like music notation, but we do work with them. Audio codec selection and support, for example, is not the WebAudio API thing. What are we expected to deliver? So for us, it's specification texts. For the WebAudio API, the Web Media API, of which a new draft is going to come out soon. And then, yeah, tests, use cases, requirements. We can do best practices, for example, performance recommendations, that kind of thing. Yeah, so a bunch of legalese. So that means that we have a few years to work still. And I will talk about the focus of the next few years in a slide or two. So now there is no version 2.0 because the change happened, and we have moved to a process where we update the main texts. It's a lot simpler than having a separate text. So you can already see the new features that we added in the WebAudio API since the recommendation got published. So yeah, it's loading, but we have an interesting way of displaying the new markup. So essentially, it's loading still. It's a really big spec. It's 124 pages if you print it. For example, what do we have? You can have so we have a changelog as always in the spec, and we have a way to display what the current spec is, what the changes are, and only the future text, for example. And so all the different new features are kind of labeled this way. So yeah, it's quite nice. So something I will show later. So new interfaces, etc. You can see all the different, and it's all at the bottom. If you only care about what's new, then yeah, just go to the bottom, and so it saves you lots of time. So I think it's a relief for us because it would be fairly hard to maintain a different specification that refers the main specification constantly, but is a separate document. It would be very hard. So we're glad we can do it this way instead. It's fairly recent W3C process. So now the meat of it, new stuff coming up. We have 3 main work items for 2022, and then I will talk about other things we have for the next year. So the first thing that I talked about yesterday in my talk would be audio render capacity, which is a way. So I'm just going to show normal markup. So it's a way to know how much of your rendering budget you're using in real time. So essentially, you start the audio render capacity object. It's going to start measuring what's going on. You can also stop it when you want. And periodically, depending on the options you pass, it's going to fire an update event. And the update event will contain a number of things. So first, the timestamp at which the measurement was performed, the average load on this region of time. For example, if you do one event every second, is going to be the average load for this second. Now you can also get the peak load, which is really interesting for us. You really don't want that to be more than 1.0. And then under-run ratio, so the number of render quantums that were rendered is going to be the denominator, and the numerator is going to be how often did the budget was the budget not met. So also that needs to be 0 for well-performing WebAudio API application. So this will allow you to have average load and peak meters for CPU, and to be able to scale down your processing depending on the device or the load of the device or any other factor. Maybe you want to increase your latency, etc. Well, you can do what you want, really. So it's fairly straightforward. A note is that for fingerprinting reasons, average load, peak load are going to be quantized to percentiles, right? So it's only going to be numbers between 0 and 1, but there is only 100 values, which we felt was enough to understand what was going on, because too much precision you would be able to fingerprint the user, as we've tried. So there's that. Then there is a bit of examples, and yeah. So this, I think, is almost ready in Chrome, and I've got all the underlying work done in Firefox, but I haven't exposed the API yet, but I will. Next, Philippe will talk about the variable render quantum. So I'm going to just open the tabs, Philippe. So yeah, if you want to.
Yeah. So it's something that that a lot of folks are very interested in, and it's something that's been talked about since Audio, at least until since AudioKinetic joined the community group back in 2019. But it wasn't always discussed this way. Actually, it started off as a separate spec called the Audio Device Client spec. I think that was initially Hong-Chan Choi that came up with it. And yeah, it's very interesting because it was a solution for doing more low-level audio stuff that the Web API was able to do at the time, to fit different use cases like the one that AudioKinetic was interested in, like running large audio applications coming from a different code base and porting it to the web. And yeah, obviously, variable render quantum size was a very valuable part of this audio device client API, because sometimes you just don't need that much low latency for some use cases. It doesn't really matter if your render quantum size is 512 or even 1024 samples. So it always depends on the use case, and sometimes you might want a larger buffer size just to save on CPU because that's more important. But eventually, after a lot of discussion, it was decided that just writing a separate spec to perform some of the same things that web audio was already doing would be kind of a waste, maybe. And there was too much overlap. So eventually, this very important concern was kind of extracted from that and brought into web audio itself. So now it's being discussed as an improvement on web audio itself. But of course, that brings a lot of concerns, like what do we do with the FFT functions that are being used in a lot of the different type nodes that web audio supports, if we can no longer rely on always having 128 sample buffer sizes. So yeah, that's why it's taking maybe a long time to nail down this spec, but it's very important, and it's probably something that's going to happen in the near future, I hope.
Yeah. Thanks, Philippe. And as far as implementation work is concerned, we are holding off on that until next year. I think we're going to start working on it 2023, because we're already doing other things right now, and it's fairly. I mean, it looks like 2 attributes really, but it's fairly involved in the engine. So yeah, we are laying the groundwork and not rushing, but it's going to be really, really good for performance. And then last one, set sync ID. So if you know the HTML media element counterpart, it simply allows to output the sound to a different audio output device. So enumeration of audio output devices is already taken care of by WebRTC APIs. So navigator.mediadevices.enumerate devices. You need to have access accepted to share, let's say, your microphone or something like this, to have access to the name and characteristics of the device to prevent fingerprinting again. And the audio context grows a new set of attributes to be able to change the output device. You have 2 ways to do this. Either you can construct a new audio context directly with the ID of an audio device. So if you do it this way, then the sample rate of the audio context will be the preferred sample rate of the audio output device. You can also dynamically set the sync of an audio context, and if the preferred sample rate of the audio output device is different, then a resampler will be inserted and possible latency will be increased because of the resampling process. So yeah, you have a bit of both style here, and we have also event handler to notify users and authors that the sync has changed. So for example, if you if you're running on the default audio device and you unplug, let's say, USB sound card, it will fire the event to you, and you will be able to react, maybe recreate your audio graph, or ask the user to select a new one, or I don't know, like any use case really. So this is not particularly hard. The problem we have is mostly about privacy and enumeration. For example, if you haven't enumerated the devices, can you create an audio context on the non-default audio output? We tend to say no, because that will expose a number of characteristics of the audio output device, such as, for example, the number of output channels, or the sample rate, or the latency. The problem is that in the world we live in, it may look like nothing, but it allows fingerprinting and making every user on the web unique. And then you've got people that will use that to track folks across the web. So we are trying to prevent this. So this API is going to only work if the user has consented to share the characteristics of their audio setup, whether it is input or output. So yeah, this is not very hard to implement, in the sense that we already do all the switching and complex things today, because you can plug and unplug and change the default audio output device, and it continues running. It's just exposing in the web browser internals. And there is also one thing, which is the non-sync. It's very useful when you don't want to output audio, because, for example, you're already outputting audio for something, but you want to analyze the audio only, but you're not going to be outputting it. This might end up going towards a design where you don't need user permission to start it, because it's not going to make sound. Yeah, so it can be fairly useful if you're playing music and you only want to do analysis with, let's say, Analyzer Node or Worklet. So yeah, it was easy to just pass the non-sync, which is a special string that will just have no audio output device. It also means that the audio context will run on probably on a lower priority thread and not on an audio callback. So that saves power as well. What do we have next? So that's the things that are coming up this year. That's the features that we're working on. what do we have for after? So I'm just there's gonna be a series of tabs that I'm gonna open on the tracker. So the things that we have worked on, spec is almost finished, but it's not merged yet. It's new native nodes. So noise generator and noise gate expander. I think we have a design. I don't know where it is. Yeah, here. So Raymond specs this. So it's very simple noise generator node. It has a few characteristics. You can seed it to have reproducible results across runs. For audio is not that important, but it's really, really important for testing. And also if you are rendering pieces, so it's the same each time. Because remember that you can also use it for modulation, right? So white noise or that kind of thing kind of sounds the same each time, but if you're using it for modulating something else, then you maybe want to have exactly the same sequence each time. You have a number of different noise types. So yeah, different weighting. And then if you want, let's say pink or whatever, you already have all the filters in the WebAudio API to very simply get your get the type of noise that you want for your application. So yeah, that's going to be that's going to be coming. I think the spec's finished, but we are focusing on other things now. Noise gate expander. So this is a very fairly old issue, reported 16th of November 2012. So essentially what we're going to do, instead of doing an expander or a gate, we're going to offer a envelope follower. And then it's going to be fairly straightforward to connect it with a delay, gain node, wave shaper, or even audio worklet if you really want precise processing. You will be able to do a noise gate and expander. You will be able to do sidechaining. Yeah, because remember that the WebAudio API compressor. I'm gonna load it. It's just I thought I had a diagram. I think. Yeah, so that's more or less what is the dynamics compressor in the WebAudio API. It's just a set of nodes connected to each other. So by offering an envelope follower with a bunch of parameters, we'll be able to implement a variety of compressor. Again, I just want to remember you the fact that the dynamics compressor in the WebAudio API is very opinionated. It doesn't work at all for all use cases. It's really a bus compressor and not really for individual channels. So yeah, so that's something we're going to implement soon. But we really go towards a composability approach and not a big complex node that does one thing well but doesn't suit everybody, etc. So we are trying to do smaller nodes that compose well instead of big nodes, which is a little bit of a departure from the original design, but we feel that it goes further. It goes further. Now, that's what's coming up right after, so probably sometime next year. And then we have categorized all the issues. So that's what we think is the most important things to work on. So I mean, it's just a grab bag of a bunch of things. So we already have things we already talked about, user selectable render quantum, like Philippe said. Audio output device, that's also fairly important. But other things that we care about, for example, phase offset of oscillators, power law automation for panning, so panning left and right with power law to keep the energy constant. Band limited pulse oscillator to be able to do variable PWM. That also has the design laid out. You can, by the way, see all that online and comment on any of those. But I mean, the PWM is like fairly uncontroversial, really. It's got a pulse width, and that's about it. Other things that we care about are, so I labeled also new features in the. That's lots of unknown on those. That's stuff that people have requested, but we haven't had lots of discussion on that. Some things we really know that we will do, for example, exposing the audio context in a worker instead of the main thread. Not so much the service worker, but regular workers, we will do that. Some things I know very little about, for example, deconvolver node has been requested, but there's been no traction by anybody else than the person that requested it. Multi-channel panner node, so to be able to do multi-channel 3D panning. Little things here and there. Channel layout detection is something that Philippe requested, to be able to know if it's an 8-channel output of a sound card that is geared towards musical application, where each channel is independent, or is it a 7.1 home cinema setup, right? So for now, in the WebAudio API, you cannot make the distinction, but we will add an API so that you will know, is the third channel center, or is the third channel just the third channel? Because it's just like regular music type sound card. And something that I care about very much is to be able to access the performance objects from the audio worklet global scope. So you will be able to make your own measurements from within the worklet to do performance measurements. More importantly, when this lands, you will be able to insert your own profiler markers from your own code. So let's say you're writing an audio engine. You'll be able to insert your own markers, for example, for your own DSP blocks, and be able to know how long it took without having to change the web browser. So that's going to be quite good. And then, tweaks on the filters, as always. Bunch of little things. So there is less certainty on all of this, but that's what we consider for the future. Of course, as always, you can, if you want to have your voice heard, just show up on this issue tracker and either use the emoji reaction things or write something a bit more substantial explaining why it's important for your use case. Always happy to have comments. Audio worklet features that we are considering, as I was mentioning yesterday. Two things. I mean, the last two really are kind of the same. We might close one because it's not useful to have two. But being able to only use WebAssembly without JavaScript and with skipping copies with WASM is something that we care about a lot. It's going to be a lot better for ergonomics and toolchain ecosystem. So that's what the last two are about, even though the title don't really reflect what it means. And the other thing was open not too long ago, is a way to just use post message without having to instantiate the worklets, right? To set things up, that kind of thing. Fairly simple, but we feel it's a nice ergonomic improvement, and we couldn't find a reason why we shouldn't be doing it. So we ended up kind of deciding that we would be doing it. So that's it. But as always, I mean, I'm gonna reload this, but so 86 issues open. You can always add more. It's you just click the new issue things. There is a little template that you have to follow so that it's easier for us to understand what's going on. And see, I mean, we have a lot more issue closed than open, so that's good. But yeah, please, as always, I think I'll be repeating myself every year, but please come and talk to us to steer the WebAudio API in a direction that works for you. As you have noticed over the last few WACs or few years, we have spent a lot of time making sure the audio worklet would work for everybody, but now it seems to work for lots of people. So we have final few tweaks, and then we might go back to native nodes because people like them, and there is obvious blind spots that we would like to address. If you can just show up and plus or like thumb up the issues that you care about. Again, github.com/webaudio/web-audio-API is very simple. It hasn't changed in ages. Yeah, so please just show up.
And also, if I may, another way you can get your voice heard is to join the community audio working group.
Yes,
right?
yes.
So that's, as far as I know, anyone can join. And the meetings are bi-weekly. And you
Yep.
can just pop up there and get your voice heard and actually discuss the issues live with Hong Chan and Paul and everyone from the working group. So this is what Audio Kinetic has been doing for the past 3 years, just on and off, not always, but it's a great way to get your voice heard. And right now, there's not that many people in the meetings, so there's plenty of room for a discussion.
Yeah, it's on and off. Some people join, some people very frequently, and some other because the agenda is posted in advance. And when you want to talk about something, I mean, we are always super happy to have you, of course, but sometimes you really don't care about what's going on this particular day. So like, it's okay to not show up. Yeah, there was a developer survey that was fairly interesting. So the developer survey was open to any person. You didn't have to register to W3C or anything. We used it. We collected a bunch of answers. There was also a free form at the bottom. So we took some time to read it. Hong Chan did some sorting of the answers, and it informed the priorities that I've talked about. So there was lots of people answered. Yeah. So here is the detail for the meeting. If you come to the Slack channel, we share the URL. It's just a Google Meet thing. It's very like laid back, no stress really. So to join the community group is it's very simple. Just make an account and click here.
It gets you on the mailing list, and I think Hong Chan posts a message on the mailing list every time there's a meeting.
With the agenda, the links, etc. So yeah, and you don't have. So this is free to enter, right? Completely open, no registration. If your entity isn't a W3C member, you don't care. You can join either with an affiliation. So let's say you represent some company or project, or you can also join as an independent person. It's up to you. You don't really have to reveal your affiliation to the group. What do I have left? Yeah, aborted project. So we won't be doing the audio device client because it was fairly easy for us to port the little features that the audio device client had, the audio worklet didn't have, and it's better to have a non-fragmented ecosystem. So yeah, we still keep the text for archival reasons, but yeah. It was. I'm just gonna click.
This was the alternate spec I was talking about when the first variable render quantum size was being discussed.
Yeah.
It was originally discussed as a separate spec, and it also had the select output device selection as well.
Yeah.
So those two features were extracted and went into Web API instead.
We felt that the difference were minimal, and then we could make it easier for anybody. And just fold the little differences into the main text, so people could also compose with the native nodes and also the worklet. And we focused on making sure that the worklet was as efficient as it could be and would work well with everything. So. Yep. Yeah, that's it. I don't have anything else to say. So I'm just gonna, as always, like if you want to contact me, I can relay to the group. And yeah, just click the GitHub thing. You've got all the repos. It's like just a regular GitHub organization. So you've got all the repos here. This one is not used anymore. You remember we had a V2 thing, but we moved back all the issues to the main one, so it's consolidated. Yes, Norbert?
First of all, just a little remark. I think you're doing an amazing job altogether, and every time I look, it works in the right direction. And now you mentioned that you felt that keeping the nodes very simple and kind of low level would be something else than others intended at the beginning or something? I never thought that. They're all pretty simple and low level. I think an envelope folder is a
there are
perfect
obvious counterexamples. For example, the HRTF panner, like does something fairly complex in itself. The dynamics compressor is like too opinionated, doesn't work for everybody. So we could have used something a bit more flexible with more options, but it's set in stone now. But yeah, generally we favor composability, and that's been the case for some time. But we didn't feel like, for example, adding a noise, like a just noise gate. If we can have one primitive, and then with 3 lines of code, people can build the type of noise gate that they feel like. We felt it was a better approach. But yeah, I mean, we don't really want nodes that are too complex or magical or implement something too specific. We prefer small building blocks. The dynamics compressor was just like a pain to specify. Yeah, really. We don't want to do that again. Yeah.
Hello. I have a question related to render rodeo quantum, which I'm very excited about. So thanks for that. And I mean, vaguely related to that, but mostly related to audio worklet. I don't want it to come across as a feature request. I know where those go. But I want to ask, because I want to get an idea of how present this is among yourselves in the development group, and also within users, if it's of interest. So my interest is in analysis, and you spoke about the audio render quantum as something that would affect performance mostly. So I was wondering if there's any talks about overlapping frames, which is something very common, especially for analysis, but also for synthesis in some cases. And I know that that is the equivalent of just having a small audio render quantum, and that would be your hop size, and then you accumulate frames basically, which is what I've been doing in audio worklets. But that gets cumbersome, and that becomes most of the code in the audio worklet to have a buffer that you accumulate frames on and to do your overlapping. Has there ever been any talks of like hiding that maybe and just providing a frame size and a hop size parameters for the worklet?
Yeah, so we kind of thought about doing it, but it felt like it was better suited by a JavaScript code because it gets pretty specific, and so we felt like the user they know best. Well, programmers know best what they need to do, and we also felt like we wouldn't be able to provide any more performance. It would be slightly better ergonomically, but it would bloat the API a bit. Yeah, we couldn't provide more performance or something that the JavaScript wouldn't be able to do. So it was left out, and we instead ensured that it was possible to implement it very efficiently by users of the API. Yeah, it's an exercise that we do very often. Try to determine what is best. Is it best in the API? Or is it best to provide the tools so that it can be implemented perfectly? And the second option is reasonably often what we favor, because then you have a long list of things that become possible that we hadn't thought of, because people have very good ideas very often. So, but yeah, that's the type of API designs that we favor these days.
Unless there are performance reasons to do it in the browser.
Exactly, Philippe. Unless there is performance reasons, or like very, very specific ergonomic reasons, or we can move the needle from including it to excluding it.
Okay, thanks.
Yep. Yep, happy to chat anytime, of course.
Thank you. So now we will start discussing about the future of WAC. Just before, I want to say something about this afternoon. So usually the workshops at WAC were sort of tutorials where people meet in a room. But this year we've got, Chrysula, maybe you can come and explain. We've got a different sort of tutorial because when Chrysula contacted me for a workshop, I thought it was the same as usual. But in fact, this afternoon in this same room, we will have 6 research papers presented like a research paper session. And I read some of them. They are very interesting, very high quality. And the workshop, Chrysula will say a few words. So I encourage all the people that are not so interested in live coding to come and attend this workshop.
Today, it's at 2 in this auditorium. We wanted to make a special theme, a special track within this conference, which concentrates on music education, online web-based music education. So it is not a workshop in the sense that there is a working group meeting or something like that. It's a workshop with 6 long papers that we would like to present, and we're really interested to, present our applications. Hopefully you will find them novel. We want to discuss challenges and we want to get connected with people that may be interested in music education. So please come, whoever is interested. We would like to present our stuff and discuss with you. Okay.
Thank you, Chrysula. So I'm going to install my computer. I've got a few slides, and now we've got 20 minutes, maybe more, I don't know, but we can keep discussing this during the lunch or even on Slack or maybe make a sort of mailing list, I don't know, about the next WACs in the future years, because some people like Norbert made some proposals. Also, I was at the Sound and Music conference earlier, and they said, why are you not with us here in Saint-Etienne? Because we were in a sort of concurrent, competing conferences just 1 month from each other. And it's true, it was a bit maybe stupid to do that. So, but I didn't know that SMC was being organized, and they didn't know that we were organizing that. So, okay, let me just plug my computer.
Tiens, l'HDMI, il est...
Okay, this is the link to the. This is the link to the workshop. That you can find the link in the call for papers. When you click on the WECML workshop, you'll see what it is about. So, but Chrysula summarized that. Okay, so I prepared a few slides, just, okay, like this. So I'm going to do the sort of master of ceremony, but it's really something I would like many of you to participate. So yesterday, Onchan, the first keynoter, said that our pie is shrinking, that web audio is more and more, a small part of the web technologies and so on. And so our domain is shrinking, and he proposed to enlarge it by, well, looking at different sort of applications and usage. And the fact is that this year, I had, some bad nights around March, because when the call for paper deadline arrived, we had only 15 research papers proposed. So I called my friends, Norbert, Anna Xambo, and all the organizers saying what is happening. And it was first because everybody was locked down due to the COVID. So, and the conference was not remote nor hybrid in that time. Well, I was hoping that COVID would disappear and the conference was only in person. So when I called some people, they say, I'm not going to come, Michel, you should put the conference hybrid and so on. So this is one of the reasons. And if you look at us, maybe not this morning, but maybe yesterday at the banquet, we were about 80, 90 people when I count the invited people. Okay, in Berlin and in Norway, I don't know the exact number, but I think we were above 100, around 100. In Paris, it was the same. I don't know in London, Mark, how many people, but my guess is that we were a bit more numerous. But of course, this year, if we count the remote attendees, we are nearly the same number, but it's not growing. And well, we are in a kind of routine, you know, so that was the idea. And myself, maybe I felt this, and it wasn't the on-chance goal, but I felt a bit depressed by the first keynote. It was a sort of little gray portrait of our community and research domain. So yes, so I think that we should talk. And also, usually today we announced where the next conference will occur, and we are under discussion. I started to discuss with several universities. Some of them are really interested, but they didn't manage to get a team involved. And as soon as their team is not really strong, they don't want to greenlight us to say, yes, it will be in this university, on this university. Because the intent this year was to have the next WAC in Asia or in the United States or on another continent. Because we, with 7 WAC, only one was abroad, on another continent, not in Europe. So for me, it's a concern. And many past organizers are here. Can you raise your hand? Norbert, Anna, Paul, Mark. So we've got at least 4, 5, including me now, organizers. So we've got experienced people about this. So what can we do? I'm just telling the different possibilities, but maybe there are more that I haven't written here. First, we can just put some more pressure on approach candidates. And this is what I did this last week, but couldn't get a green light. I will be so happy. I've been so happy to say the next one will be there. We could co-locate with another conference. So I talked about sound and music computing, but in London you were co-located with audio mostly. I don't think other conferences, other WACs were co-located, but it could be an interesting thing to do. We have a community partnership with ADC. That means that they made advertisement on their Twitter stream, on their website, and we did the same. So this is a possibility. There is the web conference that is the biggest conference about web. Usually, before the COVID, there was something like 2,000 persons sometimes, with lots of tracks and sub-conferences hosted at the same location that could attract more people. And I've been involved multiple times with Marie-Claire for organizing tracks. And for the next web conference that will be in Austin, in Texas, I am the co-chair of the web creativity track. And you will certainly get some call for papers or some messages from me asking you to come. It's open to artists, to not only geeks and computer science freaks. So this is a possibility. I know that most of the people who publish also at WAC also published at ADC, AES, or other ICMC, other conferences. So this is a really possibility. We can even imagine that the WAC disappears and becomes just a track somewhere. This occurred with Super Collider or some very targeted technologies, languages, whatever. I've got some feelings behind this, but I prefer to let you discuss that. Norbert proposed to have a virtual meetup once a year that will be free or very low of charges. So yeah. Okay. So I'm sorry. I tried to transcribe our yesterday's discussion. You will correct this when I give you the mic. And okay, so this thing Norbert will tell. Okay, because apparently I badly understood. Another possibility will be to engage private companies for co-hosting or co-organizing. The last WAC was co-organized by SonoSuite. I wasn't involved at all, but Anna and Gerard, maybe you are here? Yeah, maybe you can talk a little bit about what happened there, how it occurred. And I personally attended some conferences hosted, for example, at Microsoft Research in Seattle. It was a W3C conference about web games, and I ran there. I was in charge of organizing the audio session, the web audio session. And really, it was a great organization, and it was a good conference too. So why not? So I said all the possibilities. I forgot certainly plenty of them. No, maybe Norbert, you can just fix what I wrote and give more explanations.
So this is really not the right situation to discuss. We should be conscious of this and do our best to turn to each other, I guess, that we can discuss here the future of the WAC. My contribution is the following. First of all, I'm the person, I don't know, I didn't present at this conference. My name is Norbert Schnell. I was for 22 years working at IRCAM, and where we co-founded the WAC together with Samuel Goldschmidt. And since 5 years, I'm teaching in the center of the Black Forest, close to the source of the Danube in the digital media faculty of German university. And I'm the person to whom people go about the WAC because I'm one of the co-founders, but I didn't really steer this thing. And I think the very good news is that we are ready for a steering committee, and the WAC, even if there are all these depressing news you gave in the first slide, and I didn't understand the keynote, Huntrick's keynote like that, but well, there are some, and very honestly, before I came to give you my depressive part, before I came here, I said word by word to Michel, you know, maybe we don't need the WAC forever. I'm now here, and I changed my mind. Really, no joke. And I didn't, you know, I won't change it next week again. I changed my mind. I think this is a great community. What I like about it, and that was the concept we had with Samuel at the very beginning. There are the audio guys, the industrial audio guys. There are the web guys and girls, by the way, but guys works for girls now. And there are people like me, who are the artsy-fartsy, let's play around with this, and we are in academia guys. And many other things we always can reduce all to three. And that works, and I think that's really good and unique. And we don't find that at any other, you know, there are all these other music conferences, but they are not the web people. There are all these other web conferences, but and then there's the IES, but there, and so on. I think this mixture is really, really great and constructive and helpful for what we try to do. But I think being here and being at the other WAC conferences, we don't reach everybody who would have something to contribute to this conference. There are a lot of people out there who don't come. We must analyze this. We must maybe be more aggressive about approaching the community we want to have here and so on. So I think the first thing we need, and I'm ready, is a real steering committee, and I think the people who are potentially in the steering committee are more or less here. And then the other thing that is that in this world we have a carbon dioxide problem, so maybe we shouldn't meet when it's not necessary, on site. That's it. And co-hosting, I think, is a very good idea, but we should make really sure that it's on different continents, sorry. It's on different planets. It would be great to have it each year on a different planet, first of all. And second, that it's, you know, where the people are. the audio people, the web people, the academia, computer music people, we should really make sure that it's really on different planets regularly. And yes, I think also that we need an annual meeting. It makes sense. There is enough news and things to discuss every year. So this is all I have to contribute.
Any other thoughts?
Hello. Yeah. Hi, everyone. I'm Goran. I'm a multimedia composer from Hamburg, and I'm here as a part of the Speak Ensemble. And just a little bit related to what you said, Norbert, I had no idea about this conference until like some days ago when we received the invitation to come and play here. And this was for me quite surprising because we have a really strong computer music department that I did my master in. I work now at the HFMT. And so I think a little bit more marketing and just like spreading the word about this event would be good, because I think none of the faculty there also knows about this event, although we have people who are really into network music performance and just touching a lot of stuff that you guys are doing here. So this is like a
it's
comment.
true that maybe we didn't send the call for paper or made connections with related communities, and actually here in this area, the web audio community, I think it's me. Really, I'm not joking. All around me and my students, of course, but I'm working with a few researchers from my own team. But not a lot of people in this very bold building that is a multimedia art laboratory and masters and so on. They just discovered web audio when I proposed to Jean-François Trubert to co-organize the thing. And now his colleagues say, we must work together, we must do this and so on. So yes, of course, I think we've got a communication problem, but I don't know really how to solve it, except if we have a steering committee and decide some actions, like I don't know.
We never did anything apart from you and somebody else. We never did any effort to really coordinate to do this. So that's it. I think it was my job and I didn't do it.
Yeah, so first of all, I think you're like being a bit too harsh on, or we are being a bit too harsh on ourselves, because it's the first year after like the major pandemic wave. Very important, let's not forget that. And also I think now is the time that I think the web audio community could grow, because for almost 10 years, the web was kind of ignored, I think, by audio, like serious audio software companies. They were only targeting native. And yeah, I think it took a lot of work to get here. And we're finally, I think the web moves very slowly, much slower than any other platform, but there's good reasons for that. And I think now we're beginning to get into this phase when like serious audio will be possible on the web, and that will bring like bring a bigger community with it. Yeah.
It's a fact that it wasn't so difficult to find sponsors. Really, this year, well, maybe we were less numerous, but more sponsors and better food. So that was the consequence.
Wine.
Yes,
And wine.
Yes. You wanted to talk?
Yes, I wanted to say what is in my mind. This is my first contact with your community. I find very, very interesting works that were presented here. I had one question since my very first contact with you, Michel, and I think this may help the future of this community. I mean, I think there are similar groups or conferences that work in very similar topics, such as Internet of Sounds, for example, with Luca Truchet, or such as network music performance was a special theme in the ICMC conference in 2008. So I think if we broaden up a little bit the subject of this community, then this is an opportunity for the community to grow. I don't know many people. I don't know the background of your committee and your contacts, but this is one idea, I think.
Yeah, and sometimes people make a confusion between I am using the Web Audio API and I am making music on the web or music applications. So I had to reassure, how you say, to tell people, no, what you're doing fits the Web Audio conference. Maybe you're not using the Web Audio API, but you're making web applications and teaching music on the web or whatever. Even if they're using other tools, they don't have to be a developer or whatever.
Exactly. I was confused myself whether our applications fit in this conference. It needs to broaden up a little bit and go to anything that has to do about the internet and network. It's not just Web Audio API. I mean, this is a wonderful standard, of course.
I must say it never was, but I think it's important for this community to stay close to web standards. I think it's a major point of this conference that it's about web standards, and if I would rephrase the name of this conference from my point of view, and it's just my point of view, of course, that is creative use of web standards in audio and music, I must say. I think it's important but that doesn't mean that there are not topics that we would allow and include because they show something that is maybe today not possible with web standards, or somebody didn't use web standards for it, but it could be done with web standards. It would be stupid to exclude that if it brings us further in terms of what it means, because I think that's really the topic. What make web standards possible for making music in this world?
Other thoughts, and if people are interested by joining the future steering committee, please go to see Norbert or myself or the core members, or I don't know how you could. Well, maybe we should have a medal, something when we organize the WAC, something like some stars, on the shirt. And if we attended more than one, the multiple stars, because I attended all the WACs. You too, Norbert, I think. Okay, so we will have some, veterans. Yeah.
Yeah, but of course, the first candidates for the steering committee are.
Yeah, we like young people.
Veterans, and Jason Freeman is not here, but there are some people who are not here, and then we will, of course, nobody would be ever excluded.
And I'm curious to have Mark's opinion, because you've got more experience than us. You saw conferences appear and disappear and move and change.
I didn't speak before because I'm still thinking exactly where I stand on this, but I think definitely co-locating would be a good thing. You'll preferably with a conference that offers some complementarity, and maybe I think we participated in the web conference that some while. It's huge, isn't it? So I think that might be a mistake, because it would swallow WAC up. Maybe I don't know, if you want to keep a separate identity, but you could alternate potentially 1 year with a web partnership and another year with an audio partnership. And I have to say, of the small conferences, I really like SMC. I enjoyed it very much going there. I think I used to like DAFX, although I haven't been, so that might be just as much fun. But I think the generality of SMC and the fact it's got computing in the title probably makes it kind of a sensible partner. Do they have a standing sort of committee to? I can't remember. I mean,
Potier,
Dafex does.
yeah, I think he is not here. He had to leave, but Laurent was one of the organizer.
Yeah.
And I was there 2 weeks ago. I keynoted there.
Yeah.
So, and they were really interested by all the web side of computer music. And they told me, why didn't you organize, co-located the conference? They didn't want to swallow us. They wanted to co-locate.
Exactly. I think it's important to keep.
I am not sure that the next organizer will be interested, but at least this year's organizer, they regretted that we were so close, because maybe some people that published here could have published there and so on, or attended. So and they have concerts, they have artistic presentation, computer science presentation, scientific presentations. It's also a bit like this conference, open to developers, open to artists, open to academics, open to industrial people also. So yeah, I agree with you, Mark, about SMC.
If I think of anything more, I'll ask for the mic.
So we have still 5 to 10 minutes to discuss. After that, we will have to discuss at lunch.
Just to mention, another one is the Ubiquitous Music Workshop. It happens every year, and there's a heavy presence of Brazilian community on that one. It's organized by Damian Keller. I'm also on the steering committee of Ubimus for the last 3 years, maybe, I think. But I think that the idea of joining, it's nice. That's how it was in London. Because it was twice the people. So there's like Frederick was that for web audio conference, and I was for audio. I don't think I was on the first one. Like I presented for something that, but I also presented on the audio mostly at the same time. So it was really nice to have all this kind of people. And so for us that are not like the main places they used to happen, it's really handful to get like leave for work and to have just one ticket and to buy like and to have like, I think like it's, if you think in carbon saving, it's something that like cuts in a half, like basically.
Yes, just some ideas, maybe to make it better, with more performance for the communities. Maybe we could think about some tools to make it better, like a mailing list or something.
Yeah,
I know a lot of persons who should be there, or maybe should be aware of what we do in this conference, but they don't. And maybe I think about some people I met a few weeks ago. They should be aware of what we. And they, I mean,
we used to have a web audio mailing list, but when I tried to use it, I thought it was quite dead, so I didn't get a message for years there. And so we've got a Slack channel, but only a few of us are there. After that, I asked people to send the call of prepare to their own mailing list, but I cannot really have feedback. So I didn't know who we reached.
It's one of the one thing in the toolbox. Also, for example, a cartography of every, like a cartography.
Yeah, a cartography.
We could maintain to see in Asia, in Japan, where industries are.
Where the strong communities are located.
And for example, I'm surprised that in this conference there's no radio broadcast stations or organizations which use a lot for audio. Of course, for them, maybe it just works, and it's okay, and they feel good about that. But maybe to address them, that we need their use cases and their experiences, and their feedbacks, so that we can make it better again.
Okay.
And this iteration maybe is something that is not completely embedded in scientific academic research, because the feedback is not really the goal, but as here, there are really plenty of innovations and standards evolving every day. The feedback is really critical.
Okay.
And, yeah.
So if I try to summarize what has been said, it's that first we need a steering committee. And this steering committee take some actions like developing an audio a mailing list, make a cartography of the different communities, make partnership with other conferences, or at least talk with the organizer. We've got a community partnership with ADC that was just cross-posting things, but not more, but maybe we should discuss later. I'm going there in November. So I'll be in London at that time. So why not? But for the next WAC, I don't know yet. I cannot announce anything. Well, you'll know in time. Okay. So where, at least on Slack, this is what we've got now, and Twitter, and maybe some mails, because I've got your emails because you're registered. So this is the beginning of a mailing list. And maybe the other organizer, they catch some emails of the previous WACs.
You know, just to say that there are these three components of a conference. There's the scientific part where we publish. There is the meeting part where we talk to each other and show slides. And then there is the on-site gathering of people who, you know, eat and discuss. And these three things we can maybe slightly desynchronize. And I can imagine very well a web audio conference that coordinated by a steering committee is decentralized completely and online with local meetings where people commit themselves to organize local meetings.
So I propose that we keep discussing at lunch. Just a word, we are going to activate again the installations. And for the one of you that didn't saw Brian and Jeroen installation with synchronized phones, maybe give them time to eat, to drink and eat something. But let's say at 1 o'clock or a quarter past 1, go to see the installation. There's a very funny installation with a webcam that uses web machine learning for detecting emotions and generate music and so on. We will add speakers because the sound was not loud enough. There is also some binaural listening for an interactive application on one of the rooms there. So take some time to go there, okay?
this is a state of ensemble. It's a improvisation ensemble, and he tries to get people from
Turn on the table and
media people, some jazz people, some shoots people. Today.
All right. It's the one with the many performers.
Yes.
Right.
So this would be this thing
So this
5:30.
Okay.
So I will be here for this slot. Yes.
Yeah. Thank you.
And after this.
Vou comer alguma coisa. Posso deixar meu computador aí?
Okay. Well, nice meeting.
Fica tua.
What's your name?
I can leave my card.
Yes, please do. I'm sorry, I don't have one.
But anyhow, after this block, I would really like to chat more.
Yeah, sure. Yes, please go on. Thank you. Ah, nice card.
Yeah, this is like the whole school.
The HFMT.
Yes.
Okay. And you should give my greetings to Georg as well.
Will do.
I haven't seen him for many years.
Okay.
Yeah. Okay, we'll talk again. Do I have to talk with somebody about connecting my computer or something like that? I have the workshop at 2.
Normally it should work just fine. So what if we can try it if you want?
No, so no need to prepare something.
No, if it's only the computer for the slides,
Yeah. We have audio through.
Yes, through this. Through the
Ah,
jack. And then we
okay.
have an HDMI. Is that good for you? And then we have the adapter if you need.
I have an adapter, but I don't have an audio port on this computer. Do I have an audio? I do. I do. Sorry. Yes, I should. You're right. Yeah. I normally use it with Bluetooth headphones. Anyway, is it okay to leave my computer here?
I guess so, but it will be open. But
I don't
we
need.
are just outside, so.
Yeah, I don't want to carry it.
Okay.
Okay.
So it's just after the lunch break. You're.
Yes, at 2.
At 2. Okay.
Aline. Okay, you are. Yeah. Okay. Thanks a lot, Aline. I'll just leave this here.
Yesterday I had too much to think about, and so I decided I can handle this with all the rest.
Okay.
So this is why I was regarding you.
All right.
But
So then, yeah, but we need to retweak it
Okay.
because that template is for more than one paper.
So,
we need to
qui a
tweak the
appelé?
text so it's just one, not the.
Well, I wouldn't write Lumen ipsum Dorios.
But it says that there is a, so this text needs to be changed, right? On the SIP of recommended test papers, this is not.
So we can use together. On receipt of top recommended best papers. So there's the S.
Yeah, so we need to change that. So then what is out of the best candidates? What is the, so we have 3 candidates, right? Or do we have already one selected?
It's a little puzzling. On receipt of top
I think we should
papers
delete
for
this.
business.
Yeah, I mean, let's send it from.
Best papers award, I see.
We should remove the first one.
Yeah.
Because it doesn't make any sense. Now, with this new rules. Things have changed. I mean, first year it was not an open call, so we selected 6 papers and they were invited to write an extended version. That was first year. Second year, that's.
First year, what does it mean, first year?
In Norway.
No.
That's
Yeah.
where we started.
Great, yeah.
And then in Barcelona, Hayes said, no, it needs to be an open call. So then it was a combination of several kind of awarded papers and then open call. And this year is one best award, and then, I mean, we changed all the time, but it's good to have it here.
Well, I think like the steering committee, it's the current organizer who decides.
Yeah. I mean, I'm fine
Which
to
is fair.
adapt to.
So,
then what is?
let's come up with a nice phrase.
But what is the winner? I'm here now. So we
Okay.
can number 9.
Number 9.
Okay. Yeah. Sorry about that.
Number 9 was second for all of us, and now Laurent said in the list degree.
Okay.
That is
I mean,
number 1.
is it like Jason Freeman's?
Yeah, it's I.
Yeah. So it's the one that you're reading.
Yeah.
You're reading for.
No, and Laurent.
Yes.
Laurent agrees too.
Oh, okay.
He just sent it.
Yeah, makes sense.
So,
Well, I guess it's very original.
I really love it.
Yeah.
And I think it has this technical part, but it
Yeah,
has really
what
musical
you
part
say.
to it. I think it's important. I mean,
Yeah.
Turkey is a brilliant paper. You know, that's the guy who presented someone. It's a brilliant paper, but it's really on the technical side. And,
Yeah.
it doesn't mention.
But we can still invite, like, we need to further
Right.
discussion about who to invite for the, and for the qualifiers as well. We didn't have qualifiers.
I was disappointed about it because it simplifies things in a way, and you know, it lacks a little bit of complexity in the application.
So then, can you edit that? Are you doing it?
Yes.
Okay, and then we can, Michelle said we can print it and.
I was happy with it, with wording.
Ah.
The jury of the best paper awards
Yeah.
of WAC 2022.
Yeah. Yeah, recommend.
Right.
Good.
Could I says
With an S. Yeah. Clearly,
I-
already said it.
this paper.
This outstanding paper or the outstanding pieces from the paper entitled. The.
The outstanding paper entitled. That's it.
I told you have the title. Yeah, we need the title and the
I
authors.
will fill this in.
And this should go.
Then we should do this in alphabetical order. And that's what
We
was
should
there.
go along
Yeah, and then I will restyle it.
Oh,
And
all
I'll
right,
send it as a PDF to
okay,
Michelle.
okay, good, so we are done then.
We're done.
Okay. Yeah.
Then you have to sign.
Yeah, yeah. Good, so we made it.
Thank you very much.
Thank you. Okay, see you. See you.
Campus, on peut pas enlever le certificat. Best paper award.
Ah, certificat, ça veut dire que oui, ça sert à rien en fait, c'est doublon.
Voilà. Moi, je dis toujours à mes étudiants, écoutez, si c'est le titre, vous devez pas c'est le titre.
Tu peux le descendre, tout ça. Ça serait bien de mettre ce que tu as dit oralement en disant que c'est un papier qui montre que le standard, le standard pour faire les choses avec le standard.
Je me vois aussi, si je suis inspiré pour faire un petit truc suivant.
D'accord.
We don't need like
Join us.
electronic because I
Yeah.
still have this all of these soundscapes. What is it?
What was planned when you had everyone also we're checking everything.
Will you join us on the work
We stayed before.
Will you join us on the work series?
Yes. 42.
I think we would appreciate it.
Just to show you everything. It's something already like a bread. Prepared. So yeah, so just kind of simple. You can do like lots of sounds. And also I'm going to use voice.
So it's done. Reload and check. Yeah, and I'm removing the W3C session 3. Yes, I'm removing session 3.
He said first floor, but yeah, in some countries they
Also
like. I know in France, like zero is-
So what would you like? Would you write? Second floor?
I don't know.
On top of the stairs. From and
I
up.
can play the keyboard and the percussion with you, and I can do the improvisation.
Maybe you can call the Max Go. Max Go time.
Okay, but I can do
That's nice.
both. I think I get.
So we're gonna have the pictures.
Yeah, it's
It's
okay.
like simple.
maybe-
It's not-
I can do that.
And let me check with my ensemble. So when
It's okay, I think.
For
Yeah, that's
15, it's
And
my
Aline
keynote,
is
so I'm gonna
generating
talk
a Zoom
like for
link
20 minutes, just
that won't have a time limit.
tell about my
And that will
previous
be
work.
recorded on the cloud. So if you want to reuse it later on. Tu as généré le Zoom? Tu as généré un Zoom?
could we come in?
Okay, she's doing what?
So what should I do?
Come here.
And be with our
There will be a Zoom link below that.
Uh-huh.
You just click on it
You have instruments
and you
that are
share
for
with
all
the remote people.
Just sit on this, maybe sit on this. Here.
Yeah. It will be written like something specific, like virtual meeting room, glycol specific, glycol workshop specific link. It will be like that.
Yeah, okay.
Okay, but in a minute.
Okay. Just like play.
Ça s'arrange, ça va? D'accord. Jean-François.
Je t'ai envoyé le lien. Jean-François, we play.
And maybe Norbert, do you want to do something?
No.
No? Okay.
No, he's gonna play on the jazz session.
Yeah, you're playing in the jam session. C'est quoi ça?
If I want to be recognized, I can do something on the jam session. I'm sure nobody will.
So how long will be the jam session?
Just a second. I'm finishing that, and so everything is okay.
I think so. And maybe Jean-François will bring the keyboard as well. And the projection. I already paid for movies.
Okay.
They presented. Yeah.
It's nearly
So I
ready.
don't have the movies running on the computer.
Okay.
So we'll reach.
It's
It's nearly ready.
I should say like that. I probably was there right by the beats. No, because I need to.
Okay.
Or
what did I do?
Make a little place for a keynote and performance here on the.
Okay, so for the jam session, we need space for 7 people to play this. But there won't be everybody between jams at the same time. So we should have a keyboard and a guitar, at least, so that's.
Yeah,
I
okay.
have some.
For BCE, okay? For the jump system.
Or you have 4 keys.
For
I have an RC.
yeah, right now.
Mini jack, so
I can't.
No, I have a mini jack.
Well, it's not a problem of keyboard, it's just a problem of channels.
You have 8 channels?
I have 12 channels. Easy. Right?
Because it would be that 20 people playing in total, but 3 are leaving and changing every 10 minutes.
How much?
Tu veux qu'on teste le déhanché?
Attends, je suis pas prêt encore.
Yeah, we could do. No, maybe it would be nice actually, because I have one meeting nice, very nice quality, and the other one is not so nice quality. So nice. Yes.
We are not so much under stress.
Yes, that's what you're right.
And I think
Yes, very reasonable, yes. We just do the original movie, it's classical. And I have this very good quality. I can talk a bit more and then we just really go watch. Yes.
Just for the chances, how many computers in one time?
I think the maximum, or the maximum 5. But I have some for myself.
5 with the solar is good. Plus guitar and bass.
And I can try to change, but to check it out to change. Do you have a microphone?
Yeah.
Okay.
So we can like put on the percussion, because I have a small percussion set.
We can try. On essaye, Aline. Zoom. Et c'est eux qui vont le faire dans leur coin. Juste, ouais, ça a l'air de marcher. Bon, c'est bon, hein. Bon, j'arrête. Hein. Mais par contre, c'est toi qui dois le lancer. Tu pourras le lancer à 2h?
Oui.
D'accord, tu le laisses tourner après. Ou lance-le même maintenant, hein, si tu veux. Tu laisses tourner. Non, à 2h. Ok. So.
Thanks. Maybe you can ask, like, if someone has an extra cable as well.
What can you?
The D-jack.
Yeah, I have 4 DJ for and
Maybe I can ask, maybe the sound has also another one, or maybe another second part.
I have 3 instruments with D-jack and 1 with USA with keys, and 1 with the also. I have
Otherwise, like, if you can have 10 minutes more, I could also rearrange the schedule so that less people play this time.
C'est je te demande de ou je te demande à en français.
À faire?
Je te demande de ou je te demande à. Quelle est la forme correcte?
Je te demande
à d'imprimer quelque chose.
Oui,
d'imprimer.
Merci.
Euh,
C'est mieux avec le 2A.
Ouais, c'est confus.
oui, donc il faut faire une place à
Complexe.
Ouais,
On va la mettre à la fin.
ouais, vous l'être à côté de la console.
Donc, combien là?
Ça tape de plus. Mais est-ce qu'on stream ça? La performance. Oui.
On pourrait mettre celle-là parce qu'elle n'est pas utilisée.
Celle-là, elle peut être utilisée. Bon, après, c'est qu'à 4 heures.
Ouais. Ça plus tard.
Et elle aura besoin par contre.
Maintenant, il y a workshop.
C'est la dernière conférence, c'est l'improvisation sur le à 4 heures.
Ah oui, d'accord. Ok, donc il y a des workshops qui sont parallèles, il y en a ici.
Oui.
Il
y en a 3
d'affilée. Vous présentez plusieurs papiers en fait.
Oui.
C'est une session des papiers.
Oui, c'est ça.
Ils s'appellent workshop.
Oui.
Ok. C'est un peu confus. Et ça sera ici. Après, du coup, il y a Best Paperworks, la keynote d'Ariane aussi, et après, le truc. D'accord.
On va s'en sortir. Hein.
En plus, je ne suis pas sûre, c'est le concert.
Le concert, il est là. Le concert, il est là-haut, il est en 66.
Ah oui, c'est ça. Donc, concert with cocktails, c'est un truc quel est alors?
Alors, en fait, tu as le concert en 66, 66, le premier étage. Après le concert, il y a la jam session qui est dans le hall. Mais avant tout ça, il y a Ariane qui fait la projection de Georges Méliès.
Ah, mais attends, ça c'est la keynote 5.
Ouais.
Ah, j'ai regardé le premier après le break. Ok, compris.
Donc ça, celle-là, il faut, on va la streamer.
Oui, ça on stream. Ah, mais après, c'était dans la fiche 66.
Non, ça c'était pas prévu pour streamer. Et ce qui se passe dans le hall non plus.
Ouais, ok.
Bon.
Nickel.
Bon, à tout à l'heure.
Tout est clair maintenant.
Έχεις κωδικό όνομα του έτσι.
Ναι, έχει fingerprint. Κάτσε, άστο. Δεν είναι χαρακτήρες. Αυτό με ενδιαφέρει περισσότερο.
Ξέρεις τι, θέλω να ρωτήσω το κοινό. Όταν θα έτσι το πρώτο. Ποιος έχει ένα κρυπτονατέ και δεν το σκηνάμε.
Πες τίποτα άλλο, δεν έχω... Έλα. Μου το έχει στείλει.
Όχι, θέλω απλά να δω το link άμα ανοίγει. Θα σου στείλω τώρα.
Δεν ξέρω. Πώς θα κρίνω αυτά. Turn notifications on. Πώς σταματάς τα notification. Ξέρεις.
Όχι, δεν το παίρνει ποτέ. Sorry. Bene, che tornare più su questo di Roma. Είσαι, δεν είσαι.
Εσύ.
Εγώ άμα κάνω hotspot θα μπει.
Εδώ είναι η μπαταρία σου.
Ναι.
Αυτό είναι αυτό σου.
Κάνω hotspot.
Μήπως να το βάζεις από το σου και να συνεχίσεις από εκεί και να μην χαλάσει και μετά το διάφορο. Δεν είναι το χρόνο μας. Γιατί πρέπει να κάνουμε bypass για το security.
Βγάζει κανονικά. Αλλά βγάζει μόνο το χρόνο. Le doy una información que
Και εδώ πώς τσάβεις την Python. Όχι, η Python είναι για να κάνει το search engine.
Όχι, εγώ JavaScript όλο θα πρέπει να όλα και υπάρχει μόνο και ένα δελάχιστα θέσεις που χρειαζόμαστε να ακολουθούμε την JavaScript.
Α, οκ.
Όλα, 26 εργασίες έχουμε μετά όλα τα complexities να παίξουμε τα...
Τα CSV3.
CSV3 έχουμε πληροφορία, ανάλυση πληροφορία ανάμεσα των codes, για να δούμε εδώ πέρα τα codes και τα επόμενα. Και όλα τα events.
Και αυτά τα φτιάξαμε στο χέρι.
Όχι, τα φτιάξαμε με την απλά που δίνουν στο Java. Είναι σκεφτάκι. Και εδώ πέρα έχουμε ένα κλάστη. Για να δημιουργήσω ομάδες ματιών.
Αυτό είναι μόνο για
Και εδώ πέρα μπορείς να βρεις, μόνο harmonics υπάρχει. Αλλά μπορούμε να το κάνουμε να βρεις ποιο είναι αυτό και να το συγκρίνεις σε ένα άλλο, ξέρω. Και να δεις αποφάσεις. Αυτό είναι. Παραπάνω.
οκ. Όχι, μια χαρά.
Είναι το principle.
Δεν σου το δίνω, αλλά...
Είναι λίγο οκ. Δηλαδή, θα σου ρωτήσω λίγο. Να γυρίσω ποτέ. Πώς θα πεις να παιδέσεις. Εσύ το ρίχνεις τελικά, έτσι, δεν το δώσω. Και από το κάτω μπορείς αυτές. Ναι, ναι. Σου περιμένει και το... Si fa lista, mi si chiude, poi ti Adesso appunto l'organizzazione del sport. Pensi che se ne andare a play, anche loro, se non fosse neanche sempre duro, non c'è come più alto che ti dovrà fare un vicino. E penso sì. Se lo tagli testa capo. Sorry, is there another internet connection here inside the room?
Yes, there.
We had one.
Yeah.
When you were sent the passport. And
but I'm also using it to run, so I need to verify.
Okay.
But normally there is.
Because we have difficulties with that room. Είναι μίζερο.
Yes, say if it is.
Je peux faire une photo.
Yeah, I don't know if it's correct. Well, I received the email, but you can use it because I'm not using it. This is mine.
Okay. We have different.
Yeah, I think everyone received.
Extra
yes,
email.
yes, it
Okay.
was sent on our email.
Okay. Okay. So
Okay,
we
fine.
will check it, and if you don't have it, we
Okay,
can share
yeah.
yours.
Of course, yeah, I'm
Okay.
not using so.
Thank you.
Yeah, it's a little bit unstable to run today, right?
Yes.
Yes.
I don't know what is happening.
This is a problem for our event.
But if at the worst case scenario, I can share my connection as well. I have limited internet, so it doesn't really matter.
Because I also did the hotspot, but it doesn't work either.
Oh yeah, the 4G doesn't work in this building.
Yes.
Oh, yeah, that is a problem. I forgot about that.
But we have 3G. Maybe. I have also 3G, but it doesn't seem
No,
to work.
3G doesn't work. I have
Okay.
nothing.
We have WAC 000.
I have 4G
I have 4G.
here
Okay.
for some
So we will-
miracle. So if needed,
Oh,
I
that's
can.
yours, yes.
Yeah, I can do. Podcast.
This WAC. I'm sorry that I don't WAC. No, no.
Θα το πατήσεις, καταλαβαίνεις.
Τι να το πατήσω.
Πάτε εδώ πέρα, βάφος,
There is no Wi-Fi.
dark,
Ah,
Goya.
did you find it?
No,
I think it's the Uni's hotspot that you need to use.
Ah, okay.
Because it's like an invited account for the university network.
It's going to be
And that's to open a page, I think.
yes.
This is the thing. This one normally works better.
Tendría que sacar el libreto de Instagram, no sé si fue por esto anterior. Εσύ δουλεύει στο Chrome, δηλαδή εγώ δουλεύω στο Firefox,
Ναι, σωστά.
Yeah, very good. Yeah, thank you.
Great. Ah, ok.
Which kind of, I'm curious about which kind of technique are you using?
It's an ATEM Mini for Black Magic.
That is recording.
No, it's just a switcher.
It's a switcher, Black Magic.
Yeah, Black Magic Mini for hard ranging.
It's not recording.
No,
the recording is done on the laptop.
Actually, this one is not recording. Okay.
So you are relying that to Zoom, okay? And Zoom is streaming to YouTube and so on. Okay.
That idea, that is also a sin.
Yeah.
You can record in the Black Magic.
Yeah.
But in this case, we don't do that, but you can't connect.
Yeah, I've seen the device. And you change the scene with that.
input, so you can set.
Did you program the machine?
You can not program the
When you move the webcam of the presenter to different corners? It's already defined. It's already defined. Okay. There are. Okay. Yeah, I have a friend of mine that showed me. He told me he bought this one, but I never used it.
Too expensive.
These are the inputs.
It's a live code.
Okay.
And for the recording, and the stream for and for select transition.
That's interesting. Okay, nice. Yeah, I'm used to software like OBS and things like that, but it's very easy. That one. Yeah, it's fast. It doesn't use your laptop. I bought something for recording, but without the control. Thank you. Thank you very much.
Perfect.
The emitter and the audio pockets.
So shall we start, do you think? Wait a little bit, maybe? Oh. Sorry? Yeah, please. Okay, well, I'll start. So I want to welcome you all for being in this workshop. I was hoping for a little bit more participation, but okay, it doesn't matter. The The title of our workshop is Web Engineering Collaborative Music Learning. And of course, I want to thank the web audio people, web audio community people for hosting this workshop. And I want to especially thank Michel Biffat for all his help and for solving everything on time before we even think there is a problem. This workshop is, of course, on online music learning. And my colleague Konstantinos and I, we are here to represent a research project consortium. We have a research project which is called Music Co-Lab. And of course, it is not just Konstantinos and I. We're about 15 people, I think, including our students. And a lot of our colleagues are online. So I want to say hi from Cannes. And okay, so in this workshop, we have we had 6 submissions. 4 of them come from our project or musical lab, and we were very, very happy and very, very honored to receive another 2 papers. So one from the United States, from Kaitlin Penn and Pet and Christopher Raphael. And then we have another paper also from another Greek university in Athens. So we have in total 6 papers. This is interesting for us because we are new in web audio technologies, we are new in music education, and we want to let people know about our work, and we want to find people to connect and collaborate with. So I will start right now with the very first presentation, because I know we don't have much time. So the first presentation has the title Towards a Modular Architecture for Collaborative Music Learning. And I'm going to give an overview of the project. And then we have some presentations explaining a little bit more about some components of this project. So like I said, it is a Greek national project. We received funding. Our proposal was approved about 1 year ago, so last June. So it's a really new project, and everything is under development, more or less. It's work in progress. We are 3 partners. The Hellenic Mediterranean University is the university where I come from, and it is located in Crete, very south of Greece. Then the Aristotle University of Thessaloniki Department of Music Studies, it is located at the north part of Greece. And we have 2 professional jazz musicians in the consortium, Andonis and Dimitris. They are very good jazz musicians, and also they have initiated the development. They've done the development of an application called Genius Jam Tracks. Maybe you want to visit this page. This application is offered for iOS, and it aims at musicians wanting to practice on jazz improvisation. So some of Genius Jam Tracks is inside our project, and that's why our project has a bias towards jazz learning. But of course, we're trying to make something for any kind of music learning. Yes. So our objective is to provide a fully web-based environment for collaborative music learning. And when I say collaborative, I mean that people should be able to collaborate not only asynchronously, but also synchronously. And our approach is to develop a modular architecture which comprises several little modules that these modules are interoperable and may be combined in order to allow realizing the intended learning scenarios. So in terms of music pedagogy, of course, we're not specialists in education theories and things like that, but it seems like we adhere to theories of social constructionism and social contractivism, which state that people work together to construct artifacts and that learning of individuals takes place because of the social collaborative interaction with these artifacts. So our platform aims at allowing constructing artifacts, exploring artifacts, rendering, distributing, sharing, interacting, manipulating, and so on. And what do we mean by music learning artifacts? We basically have two things. We have digital audio files, digital audio recordings, as well as music notation files in different formats. Both of them can be in different formats. So the first requirement for music learning, we want to address situations, first of all, what does a teacher do asynchronously in order to create a course. So one of the main things teachers do today is to interact with a learning management system, an LMS. I guess that most of us have been interacting with learning management systems. For example, Open eClass is one of them. Moodle is another solution for open source learning management system. So one of our modules is a learning management system, which is based on Moodle. I will show that a little bit later. And this allows teachers to create the course structure. Also, we want to let teachers have access to a large repository of music learning artifacts. So that's the second module of our platform. We have built a data repository where people can upload their learning material. And this data repository is the main subject of the next presentation, so I'm not going to get into very much detail into this. It actually incorporates several intelligent functionalities for exploring new material and things like that. Also, we want teachers to be able to construct new material, so to say, record their performance or build the score from scratch. And that's more or less it about asynchronous interactions of the teachers. Now, asynchronous interaction of the students, we consider that the student would like to receive learning material, would like to create their artifact, which usually in music corresponds to a recording or a score, maybe, if we're talking about composition. And a student would also like to have some sort of automatic feedback asynchronously. So we provide some mechanisms for audio analysis. For example, we incorporate some mechanisms for beat and chord extraction. And then, of course, we want to accommodate synchronous collaborative lessons. This is a virtual room where people meet, students and teacher, and where they can interact simultaneously, either by creating new artifacts or by modifying existing ones. And our general architecture, it comprises 3 servers: a collaboration server, a conferencing server, and a music generation server. And each of these servers has different modules. Like I said, the modules are interoperable, and you may choose which ones you want to use in your setup, in your learning lesson. So if I want to put numbers in these modules, at the moment we have 6 modules. One is the learning management system. This is just a screenshot of our learning management system. Actually, since I plan to show a couple of things, our website is on address musicolabates.ugr. You can find some information about our project, our goals, our partners, and so on. If you try to log in, you log into Moodle, to the learning management system, where one can find different courses or can build new courses. I won't get into much detail because I think that most of us have been using such systems. And so this learning management system is in fact connected. It authenticates user. It gives them roles of teachers or students. And through these roles, people get access to our data repository, which is, like I said, the focus of the second paper. So I'm not going to get into much detail. This is something we developed from scratch, and it has several mechanisms that you will see in the second presentation. We are using the Wave Surfer widget. I suppose most of you know this, as a sound editor to display waveforms and well, every artifact is associated with metadata. So within this platform, we are able to show metadata, suggest automatically metadata, edit metadata, and things like that. And then another component is the notation editor. This component is actually based on an open source solution which is called the Verovio Humdrum Viewer. Maybe some of you know it or have used it. You can see the notation editor. I'm sorry. Yeah, here, for example. So the idea is that you can load scores either from the hard drive of the user or from the repository. This is an example of a score. These scores may be used either asynchronously, edited asynchronously by teachers or students, or they may be edited synchronously. So this is one of the main modifications we've done on Verovio, and this is the subject of the third presentation in this workshop. We have tried to implement collaboration mechanisms like, for example, those similar to those used by Google Docs to allow collaborative editing of this score. Other things are that you may edit a chord, for example. You may change a chord, and then this connects to a component of our system, which is called music generation server, to retrieve a different score according to what you require. Okay, maybe this is the time when I have to talk a little bit about the music generation server. This is a server that maintains, at the moment, it maintains symbolic artifacts for jazz standards. So it allows retrieving score files according to a specific complexity, harmonic or rhythmic complexity. And you may send requests to this server to modify these files and modify them in terms of two things, mainly to ask for reharmonization to change one chord or to change the chord sequence according to a different style. So Verovio Humdrum Viewer is one component that we based our implementation on, but as you will see, we've changed it quite a lot. So, for example, we have added here something like a sound editor. I would like to try to show you, to demonstrate one of the functionalities of this component. I'm most certainly sure that it is not going to work because this is really under development, but please let me present the idea at least. So we suppose that one student loads this score and wants to experiment, wants to practice on this representation of music. So one of the things he does, for example, he or she does, is if she may wear speakers, headphones, excuse me, and listen to this a sound rendering representation of this score. At the same time, this may be used as a backing track, as an accompanying backing track. So at the same time, the student or the teacher may wish to perform a solo based or perform the same piece of music at home. And they may in fact record it through this little application up here. So for example, the sound is only, yeah. Excuse me? This is not connected. No, it is. The output goes to, yeah, I'm sorry. Yeah. External headphones.
The first one?
The first one. In Audacity, all right. Do you know where?
This is Core Audio, Macro Pro Mic, and Macro Pro Speaker. Move to the right, move to the right. Right, one more.
Right. This is there's only one. Maybe. Yes. You are right. Okay. Okay. Audacity, and then. Well. Where output? Anyway, yes, the thing is that this application can hear, so I'll try to do this again. So you produce a recording of your performance, which you may, for example, align it to the score. We do some audio to score alignment, not non-real time, offline. So there is this button here that does the alignment. And then I may choose one note and request that the waveform goes to that point of the performance. So you can imagine this can be quite useful for long pieces, for example. And we have a second button here, which does audio signal analysis, and it is not implemented yet. But our goal is to do some automatic chord and chord detection and beat tracking, which will be displayed on this waveform. Yes, and the other component of our project is this thing called conferencing server. This is a video conferencing server, and since we wanted to use web-only solutions, we decided to use Jitsi Meet. I have a separate slide for this. I'm sorry. Jitsi Meet for creating a virtual room where students and teachers can meet. Of course, ideally, we would have liked this component to have to satisfy the requirements of network music performance systems, so to say, to have very low latency and to have very, very, very high audio quality. But as far as we knew, at least up until this conference, this is not possible at the moment through a web browser. But I see that new implementations of the web audio API may enable such things. Well, may enable mainly that we have more control on the audio device, because one of the main things in network music performance system is to have very, very small audio buffers, which is something that you cannot control at the moment. So we use the video, Jitsi as a video conferencing component, and this may be activated again from here. So you may require a room, for example, we may meet at a room called Jazz Impro or something like that. And then I may connect here to join a meeting and at the same time edit the score and the audio file. Okay, as you can see, I'm not going to get into any more detail. I think the time has passed. As you can see, at the moment, we're, like I said, our project is very, very new. It's under development and it's work in progress. And at the moment, we don't do any low-level development stuff. So what we wanted to do is to reuse existing solutions, mainly open source solution, and see if we can accommodate all the requirements of music education. Of course, there is a plan for getting hands-on implementation with more low-level stuff. Already to integrate all these tools all together, it requires a lot of work, believe me. And well, regarding conclusions, I think I've already said most of this, but one of the main problems at the moment is we have not conducted any evaluation experiments. Of course, evaluation experiments will reveal the real thing, what is the real problem. At the moment, we're just developing, trying to provide as many collaboration and interaction affordances as possible, but we have to actually see this in practice. So that's the most obvious thing one can say. And the other thing I wanted to mention about our project is that, first of all, we have two research priorities. We want to experiment on simultaneous collaboration over the web, see as much as possible how people can collaborate on audio and music simultaneously. And of course, research as audio engineers that most of us are, one of the things we want to check is how music information retrieval functionalities could be incorporated in such a system, and how, if at all, they could help students or teachers to reach learning material or to improve their learning experience and engagement in music learning. So that's all from me. Thank you very much. I've put some links here where which you can try and see our different components of the project. Thank you for listening. I don't know if you have any questions, comments. Thank you. Yeah.
Thank you. Just a quick question. My name is Latko. I'm from a music university in Hamburg, and
all right.
Our ensemble will perform the closing performance.
Yes.
So, being a jazz musician myself and teaching at our jazz
very
departments, my compliments for. I think it's a beautifully integrated concept.
Thank you.
Kind of fragments of that I see exist in the commercial domain, but to integrate it in such a way, I think it's a very valuable undertaking. At the same time, my question is, where do you really see the application? So to give you an example, in the past, unfortunate Corona times that we shared, I wished I had a tool like that, but more than that, I wished I wouldn't need a tool like that. You know what I mean?
Yes, of course.
So, thank you.
Yeah, thank you very much. There was no question.
That was the question. Where do you see an application for the finished product?
Okay.
As we always, I would assume, would prefer to meet in person and to play in person especially when it comes to jazz music.
Well, I mean, as a jazz musician, I suppose you do know that well-known tutors offer master classes and things like that, and they have to do that through the internet. I mean, we cannot take the airplane anymore and go here and there every now and then and do our classes. I know a lot of jazz musicians who are teaching through the internet. No.
I can speak to that a little bit too. My nephew, who is a guitar teacher in the States, very, very busy home studio. And when COVID hit, he went completely online. He already had a very good online presence. He is busier now and making more money now, teaching students all over the States than before COVID. And it also, with these kinds of tools, it's possible. You want to study with Richard Davis in New York City, but you live in San Francisco. You can use systems like this that do exist. There's string teachers, private lesson folks, and it works both ways. The teachers are becoming more and more facile with these kinds of systems. The systems are becoming more and more
efficient for this type of interaction and sophisticated.
The question here again is where you're going. There was a slide yesterday about hammers and nails. And it appears like you're building the hammer and are searching for a nail right now. You're throwing everything you can possibly throw in. Where are your domain experts? Where are your teachers who are saying this is what we want? I think Hong Choi also spoke a little bit about this. It works from both sides.
It's true. Actually, the third partner of our project, like I said, it's two professional jazz musicians, and Donis and Dimitris. I think one of them is participating actually. And they may reply if they like, but requirements and everything else we have get from these people, and they have, of course, students and things like that, and they are developing themselves applications for music learning. The thing is, we didn't collaborate in evaluation yet because this is just a starting point. You know, we just started to develop things. We discuss together and say, is this useful? Is this useful? But now is the time to schedule our experiments and see whether this is really valuable or not. Maybe it's not, I don't know. Yes, please. No, yeah, I know. I know, of course, but there's always one case like that.
So in your conclusions, you mention evaluation, and I'm guessing a little bit about what you even mean by evaluation. Are you talking about looking at the student performances and trying to evaluate correctness to the extent that it's possible? Are you talking about evaluating your own success in putting together all of these different parts? Can you explain a little bit more what you mean by evaluation?
Okay, yes. We want to see whether this type of interaction is through our system is effective, and whether it enhances student or teacher engagement in learning. Because, you will see on the next presentations also that it is we are trying to provide mechanisms for exploring material that you may want to experiment or you may not want to experiment. And we want to see how each of these tools is useful. So I'm not sure if this is your question. Yeah, we plan to conduct some interviews and things like that. I don't mean an evaluation experiment in the sense of measuring things or benchmarking. We just want to monitor the interaction of people through the platform and whether there's something missing or not, and whether something is useless maybe. Yeah, we're not that many. It's okay. Yes, we have some people connected through the internet.
Okay. Since you have the score following, this allows you to say some objective things about the performance. You can say something about rhythm. I don't know what the right standard is, certainly not metronomic rhythm. You can say something about pitch. You can say something about vibrato, maybe something about dynamics.
All right. Yes, I see what you mean.
To give any
feedback
about
to
accuracy, or maybe even something more aspirational.
Yes, it's true. Actually, we plan to provide some visualizations of student feedback, which originates from automatic analysis of audio. Is that what you mean? You know, quite a lot of platforms that deal with music education, for example, I don't know, Musician or things like that, they provide student feedback about pitch, for example, or about time alignment. We don't mean this as an evaluation of our platform. We mean it as providing user feedback to their performance. I don't know, is this answering your question?
Well, I don't want to go on and on about this. Other people might want to.
But we could, yeah.
People might want to ask questions. I'm just sort of curious what it is that you intend to give feedback on.
All right. Yes, I see. Well, with my students here, for example, concerning score following, we plan to provide feedback as to how well aligned is a performance of a piece. I know that when you are learning music, you don't just perform from the beginning to the end. That's what we were discussing, by the way. Yes, I'm sorry. So we will switch to the next paper, and maybe this will bring some more questions for music learning, but we can, of course, discuss about it in private afterwards. So thank you. Yes? It is online, yes. The second paper is, it's about the data repository and the intelligent repository of collaborative music learning. And it's our colleague Michael Kallochristianakis who is going to present it. I don't know, maybe I can help you with this. Yeah. Do I need to remove this? Okay. You cannot send it to the...
I was working this morning. I don't have it. Michelle? What is the big? Because I was it's not working anymore. It's just that this is not set to the. No, it's when I click here, it's supposed to go there, but it's not going there. And I don't know that. How long is this?
So it looks like we cannot have the next presentation at the moment, Michali. Maybe Demosthenis is there to present his paper?
No, anything that is online is not going to work.
All right. So the only thing that is not online then is Kaitlin and Konstantinos.
Yeah, and then as soon as David is back, we can go back to the
Okay.
Oh, sorry.
Okay, so guys from Greece, we're going to do first the presentations from the authors that are here in this room, and then we will have the assistance of a technical person to show your presentations on the screen. So, this is a presentation from Kaitlin from the United States. And you need to connect here, huh?
Okay.
It's okay if I unplug this? You want the adapter?
Yeah, is it Firewire?
Yes.
Okay, great. Wait, that's USB-C. Let's see. So I have another. Should I plug this in the other one?
Okay.
Oh, so I have this converter where this can go in here, this will go in the HDMI.
I have an HDMI as well.
Yes, you don't.
Well, this is the only thing that'll plug into mine.
Oh.
Let's see. Could I?
Maybe, do you want to use my computer?
You want to put directly?
Yeah,
there?
could I do it directly?
Yeah, but then you need to be there.
Oh, okay. That's okay.
It's Thunderbolt to,
Thunderbolt to
HDMI.
I could just present from there too if that.
Yeah, we can put directly there. This is the only way I can see. But then maybe we come here. Okay. Thank you. Sorry, it's an old.
This is your microphone and the audio cable is over there.
Oh, awesome, awesome. Oh, perfect. Thank you. All right, great. Let me make sure the audio is connected. Let's see. So it should be headphones here instead of the BDM HDMI.
Yes.
Okay, great. All right.
No, but our guys collaborate with the bass player. One of the presentations is already placed. Yeah, I understand. It's inside.
Oh,
I think we can start.
Get started? Okay.
So this thing you put on the other way around.
Oh, okay, okay.
Like
Sorry, I've never
this,
used
if I
it.
can help.
Oh, yeah, sure. Thank you. Oh, okay, okay.
So I think we're good to go?
Yep. All right. Awesome.
So we need to rush a little bit because there's a concert going on afterwards here.
Mm.
We cannot delay it any longer. So
Okay, I'll try to be fast.
let's try and make it
Mhm.
short.
Okay.
Maybe one question per presentation, a fast one, and then we can talk afterwards. Thank you very much.
Okay. Awesome. Well, hi guys, I'm Caitlin Pett. I'm with my co-author Chris from Indiana University. First of all, I want to thank everybody for this really cool conference. We learned a lot and definitely very inspiring. So today I'm going to be presenting a new approach on virtual ensemble assembly. So this is asynchronous assembly of classical music, chamber music. So note that this is a proof of concept. We don't have an app yet that people can try, but we hope to get there at some point. Okay, so motivation is fairly obvious, but I want to talk a little bit about it.
So during COVID, as everyone knows, there was a lot of interest in online performance. Mark yesterday gave a really good introduction of the synchronous space. But today I want to focus on the asynchronous side, which was actually very, very popular, both for professional ensembles and even, you can see here, this is a 2020 concert from my old high school. So people from all levels really gravitated toward this method. And one of the reasons is because it's just so easy to put together. All you have to do, everyone records their part with some kind of set reference track. And then assembly is very straightforward. Just have an audio editor or video editor, stack everything up to align with the reference track, and voila, in line. Seems like it was played in sync. So, but there are also obviously some drawbacks to this approach. So first of all, most obviously, no real-time communication. You're just recording alone in your room. All the synchronization is an illusion. So for us, this is not what we're focusing on because there are some inherent benefits to asynchronous. For example, you don't have to be in the same place in the same time. And with our new method, there's going to be some other benefits as well. We're also, yeah, why don't I just move on from now? Okay, so into our new approach. So what we're doing is completely eliminating the reference track, which makes recording a lot easier and also allows for a lot more musical expressivity. So for classical musicians, unlike a lot of modern genres, playing with time is a very important part of musical expression. You choose your tempo for a reason. You may want to have rubato, speed up, slow down, have a retardando at the end of phrases. So all that are very important aspects that are not captured by the click track performance. Because if you're with the track, you decide to do a retardando, boom, you're off from all the other players. So what we do is we replace the reference track with automatic score alignment, offline automatic score alignment. So then we know exactly, okay, this part is playing each note at these exact times. And once we do that for all the parts, we can then stretch them note by note to an arbitrary new timing scheme where everybody is in line. So moreover, we can design this new timing scheme in ways that will preserve the player's original expressivity and combine each player's expressive intentions together in some kind of way. You guys can evaluate how successful that was, but we worked on several approaches in order to make that happen. Okay, so first I'm gonna very quickly run through just our technical pipeline for how we start from recordings and turn that into an assembled piece. So here there's an example from one of the groups that we worked with. It's Brahms Clarinet Trio. We see the clarinet score up top. Oh, I have no mouse, okay. Clarinet score up top and the spectrogram of the audio in the bottom. Okay, first thing we do is line everything up. So match whatever note onsets are in the score to the note onsets that you could see in the original audio. And lastly, what we're gonna do is stretch that on a note per note basis to fit some arbitrary new timing scheme. And if we do that to all the other parts and stretch them to the same new timing scheme, they're gonna be aligned together. Is it changing? Okay, great. Okay, so now I'm gonna take a little bit of time to introduce who we worked with. So we ended up working directly with 3 ensembles, ranging from undergraduate music students to really top professionals in their field. So a thing to note about this is there's some important differences between these ensembles besides just their level. So they have very different levels of familiarity with each other. So our first Brahms ensemble was an undergraduate chamber group. They did it for coursework and they started their group pre-pandemic. So what that means is they'd rehearsed together in person and had some idea of what they wanted their group music to sound like. Our next group was based in UDK. So they had never played this Mendelssohn octet together in person before, but it's standard repertoire. They all knew the piece. They also all knew each other. Our last group was the most diverse. So my sister is a clarinetist at the Yale School of Music. So we ended up doing this collaboration where me and Chris were on oboe and the other wind players were students and faculty from the Yale School of Music. So here, not all of us knew the piece, first of all, and we'd never played together as a group. So as a result, compared to the first 2 pieces, there was a lot more variation in interpretation. Some people took it very fast, some people took it very slow, a lot of different phrasings in there. So these things introduce some issues that we had to work through later on. Moreover, notice that these are two periods of two periods of classical music. So there's the romantic stuff and there's the classical stuff. Romantic music and classical music, there's different standards to what is appropriate in terms of rubato. So romantic music can accept a lot more rubato. For classical music, it should be fairly steady to be considered tasteful, quote unquote. So that's another thing that we had to take into consideration when doing our assembly. Okay, so to begin with, I want to describe a base case of basically an assembly where we had no expression whatsoever. So what we did here was we just took the score positions, multiplied it by a constant, and those were the times. So this is very, very metronomic. If it's quarter note equals 60, a quarter note is going to be 1 second, half note is going to be 2 seconds for every quarter note and every half note in all of the parts. So people were impressed that it worked, like they sent in their recordings, they're impressed that something came out the other end, but they didn't like the recording. So our favorite quote was from the Yale horn faculty, and he said, "Oh, it's as if everything that was B was just extracted from those notes." So he really, really did not like this. But I mean, that's a really fair point, and it gets to the heart of the matter because all of his tempo expressivity is gone. So this also shows the importance of having these algorithms that can help maintain some of those musician intentions, so they see themselves as having agency in creating the final performance. Okay, so next, you might be wondering, okay, what does it mean to preserve the timing expressivity? Because expressivity is such a nebulous concept, right? We had two ways to operationalize this. So first of all, you could say that preserving the musician's intentions is preserving their audio exactly. So whatever timing they had originally is whatever timing that should appear in the final version. So this works in some cases and can be very effective, but that's also a very constricting definition. So we also, to allow for more transformations, we had this second possible definition where expressivity preservation is timing pattern preservation. So that means if you scale the audio, make everything slower, make everything faster uniformly, that's preserving exactly what the player intended. But if you deform the audio, so let's say one note gets longer and everything else stays the same, that's going to be degrading the expressivity intention. In practice, it's not quite so simple. For example, in Mozart, one thing I did was for some sextuplet figures, I played it fairly quickly and applied one note longer because of that. And when slowed down doesn't work as well, but usually it's very good assumption. Okay, so we use these three strategies for approaching, and some of these strategies work better for certain situations than others. So I'm going to go into them. So our first strategy was modeling chamber music expertise. So basically what this is about is saying, okay, we have these original audio tracks and any type of deformation is going to lower the expressivity that's translated from the beginning. So we want to put them together in such a way that they're together, but we want to deform it as little as possible. So how do we approach that? And what we did was we looked toward chamber music knowledge. So according to methods that teachers tell students how to put together chamber music, what's an appropriate way to do this assembly? So we tried our first thing called follow the leader. And in here, we have a designated leader assigned for every part of the score. So that leader part is going to have their timing exactly copied from whatever they played in their original recording, and everyone else is going to be squished in order to line up with them. So what's nice about this is you could have leaders that switch off. So for example, maybe one part is more important or a better leader in a certain area, one part is a better leader in another area. You can arrange this framework so that different people are leading at different times. Let me play this for you to see, so you guys can get a taste for how it is. I'm going to be reducing some of the audio examples, but For now, let's give this a try. Hopefully audio works. Let's see. So this is our Brahms group. No. Let's see. About this Mac. Nope, wrong one. System preferences. This should be just the sound, I think. Output is headphones. Oh, it should be HDMI? Oh yeah, you're right. Thank you. Okay, sorry guys. I'm sorry. Okay, I'll start from the beginning again. Okay, so you guys can see there's a video with there, and we just stretched the video frames the same way we did the audio frames. So that's the Brahms group. I'm also going to show a recording of the Mendelssohn group here. All right. So I thought both of them sounded pretty good, but we got radically different responses from our ensembles. Well, let's start there. It did start there. Amazing. So the Brahms group, the one that you first saw, they really liked their rendition. They thought it really, they didn't say too much. They said it was cool, but it seemed like they were happy with what it was. The Mendelssohn group was very unhappy with that rendition. And I think the main reason for this was because of the way that we determined the leaders. So we used a very simple heuristic, which is whoever's playing the fastest notes is going to be the leader. It makes the actual, faster, okay. It makes the actual assembly a lot easier in that way. So for Brahms, basically that was a good assumption lined up with musicality. For the Mendelssohn, that was not as good of an assumption because that meant the second part had most of the leading. So they said first violin is not leading. That doesn't sound right. That's why. Okay, and this doesn't work with for the Mozart. I won't go into too many details for now, but basically everyone was recording at different tempos. So if you put it together, it's not going to be steady anymore. Okay, so our second way is, let's see. So our second way is pretty similar to the first way. It's basically a reference track method, but we as the engineers determine the reference track. So we say, okay, beginnings of measures should align. So we stretch the measures all evenly so everyone aligns on a measure by measure basis. I'm not going to play this for you, but it is a very interesting example if you want to check it out. So the players toward this example said, okay, it sounds very expressive, but it's not idiomatic. So they're saying, okay, people are wiggling around too much. This is wrong. This is Mozart. It's supposed to be a lot more steady. So it showed a lot of expression, quote unquote, but not in a way that the players thought reflected what they intended. Okay, so next, optimization. So here we're just using an optimization method to specify what we want in the final recording and leave the how to the optimization algorithm that we're using. So in Mozart, we care about preserving expressivity, keeping things in sync, and having a steady tempo. So we translated each of those qualities into loss functions and inputted the initial note onset locations into our loss function, optimized it, and then we got a something that was able to capture all of those qualities. I'm going to play like 2 seconds from this example. Okay, so This version was actually the one that the players liked the most out of everything that we did. And they thought that, in contrast to the last one, it was very steady. It was very appropriate. But, oh, next slide. But one other comment they said, it was like, it's nice, but it's not great. So it's appropriate, but I mean, it's not what we would have done if we were in person together. Okay, last, I'll go through this really fast. So this is a simulation-based method where we're trying to model the musician's cognitive processes from moment to moment. So we have these agents that say, okay, I will go, it's like a game kind of thing. So one person will move, other people will respond to them, and then everyone keeps moving in turn until you have a timing sequence. And the goals of this game are determined by, okay, so you want to follow everyone else, be with them in the next T-1 time point. You want to express your musical opinions, so show whatever interpretation was from the original recording, and you want to help the ensemble maintain the correct tempo. Okay, skip that. So this version people liked, but they did note that if we kept all those weights of each goal constant, then it comes apart sometimes, but it's fairly easy to tweak it. So in the parts where it falls apart, just make them follow more, listen more. Though this is, messing with this is a little bit complicated though, so it's gonna need a little bit more work on our end to sort it out. Okay, last slide. All right, we're there. I already said this is a good alternate for reference-based asynchronous performance that is still very popular in a lot of scenarios. It could also serve as an aid for synchronous performance because chamber ensemble playing is a learned skill. So being able to align with something complicated while also maintaining musicality, that's something that's hard for people. So this could allow people to, if they're having trouble with a section, record it themselves and then see the algorithm put it together and see how they could sound if everything was to work out properly. Another interesting application is for controlled music synthesis, where this is a version where you can very closely control the timing by saying, okay, I want this time in the final version to correspond with, I don't know, this event in a video. So it allows you to manipulate music so it can align to other pieces of media. All right, I'm done. Thank you, guys. Oh, thank you.
Is there one question, maybe? You have one?
This demo would be even more interesting if we could hear the original raw tracks and then the mix of all of them together so we could hear A/B test what changed. And remind me again, the raw tracks were recorded how? Just silently or with any kind of reference?
No reference. So we just told them, here's the part, go record your piece however you want it and send it up.
So the oboe player in your replay there was just sitting there silently imagining when he was going to come in for the Mendelssohn?
Well, actually, the nice thing about score alignment, I didn't really talk about this too much in the presentation, was that it can parse the rest automatically. So basically, when I was recording this part, I was like, okay, I have a rest. I'll wait 3 seconds and I'll go to the next part. And the score alignment was able to capture that and allow me to record the whole thing without waiting, I don't know, say 16 rests between part and part.
Thanks a lot. It sounded, to me, it sounded very, very natural. Anyway, okay, so it seems we can go to the next presentation, which is remotely. So my colleague, Michael Kallo-Christianakis, can we connect? Kaite, thank you.
Okay, so we are online, but apparently Michael isn't.
Michael, Mihaly?
I am online.
Oh, sorry. We couldn't see you.
Shall I share my screen?
Yes, please.
Right. So is everything okay? Shall I start?
Yeah, you can go.
Right. So I will present you the second paper. This is a presentation, but the second paper. I am Michael. I am an IT engineer. So
Yes, we can hear you.
Right, so which one is going to be? things must be evaluated from our perspective. Moodle is not always easy to manage, especially in terms of files and content. So we had to decide how.
Do you, excuse me, do you share your browser? Because we do not see your browser. Is that what you're showing or the slide?
The browser.
No, we cannot see the browser. Do you have two screens? Did you share the?
Right.
Just share the whole screen because we see the PowerPoint.
Is it,
Yeah, now it's better. Yeah, thanks.
so functionality.
Intelligent.
We can execute a suggestion. So we have now spawned a process, an individual process that present as much as possible. And once the exact same function. If we want to search for similar results, we may use this method developed by Dr. Zervas, which compares the input to the files, which are also sampled, and produces That's all
Is
I
it-
had to present you, or at least most part of what I had.
Thank you, Michali. So there is time for one question or maybe two, Michelle? No. Is there any question from the people who watched this presentation? Yes, please. So Christopher Raphael.
Thanks for the nice talk. So you're pulling in a lot of different elements from diverse, disparate sources. I am missing what your vision is for what you're trying to do. I thought this was about teaching people jazz. And you showed all of these examples of basically music information retrieval kinds of things. How is that relevant to teaching jazz?
So to me, it's obvious from the technological point of view. I mean, we're trying to help people do their job. So they have the LMS model. They have their content here. They have organized their material, and maybe they want to organize their files better, because if you attempt to manage a lot of files in Moodle, you will definitely see that it's not very user-friendly. Its CMS features are not there. It's not about managing files, let alone musical files and musical content. So we're thinking maybe musicians would like to have a database of files, and maybe they would like to share files, so they may have public files and private files. If there is a database, a repository such as this for musicians, they would like to play a file, an MP3 file or a WAC file, and if they had a KRL file, which is a score, they would like to click a button and have the score open in their audio, and then edit the score. Or make a call, a teleconference with by means of this or any other tool. And if they use the CMS for real teaching, maybe it would be good to help them organize their data on a second level, not only know and register file names, file types, but also let them include metadata. So this let me create a tag. They could order my project guitar. That's a new tag. All right. So in public files, this file, Live Jazz, now is tagged because it's part of my project for my guitar lessons, let's say. Or if this functionality, also this functionality contributes.
Excuse me to interrupt, Michali. Michali, excuse me to interrupt. I think you were asking about the intelligent part of the repository, the intelligent functionalities, how they contribute to learning.
That's where we are going.
Okay.
You gradually want, the musician will gradually need more and more intelligent functionality. So they will start to maybe want similarity matching, because they want to find something similar than with that which they expect they want to teach or play. So these things pile up from a technological point of view. We have to consider them. And since they pile up, because it is functionality useful and because technology progresses, we have to evaluate them sooner or later, and there are models that for technology evaluation. I'm not sure about if they consider music, but this would be an interesting question, an interesting aspect from my point of view. So this is the vision. It's an element.
Michale, we are running out of time. I'm sorry. Well, thank you. Thank you for the question, and we can discuss everything afterwards as well. So we need to go to the next presentation with our colleague. Our colleague, Professor Demosthenis Akoumnianakis, is part of this project from the Hellenic Mediterranean University. And he's about to talk. Yes, I think IST Lab is IST Lab. And yes. Yes, we can hear you, but please please don't make it too long because we are running out of time and they have a concert afterwards in here.
I will not take more than 5-10 minutes. And what's most useful for you, I will not take any questions.
Okay.
Let me just make a brief introduction by saying that We have other measures in physical to assess physical. But I think just to get to the point where I can conclude. In the hope that I might even get one question.
Thank you, Demosthenes. We have one question from the participants in the Zoom meeting. It was a hand, man. What is it called in French? No? Okay. Okay.
Should I read the message?
No, no.
The chat, sorry.
Is there one question from the audience?
So it's the beginning, just the beginning of your project, right?
Yes, it's just the beginning.
Okay, because it looks like more sort of, yeah. I said it, of course, you've got already some tools online, but it looks like more a sort of a position paper, what you plan to do, what you would like to do. And I think that some of the things you saw the previous day might be a good addition. I'm not talking about the tools exactly, but you saw some work that people are doing, like Mark Bernstein for collaborative music, or maybe maybe the presentation was not so interesting by my students, but he made some, it's useful for teaching also, sound processing and such things. Or I think because you spoke of some abstract concept like we must assemble bricks to make something better and so on. So yes, I think you can by looking at what the community here is doing, find some interesting tools and collaborations.
Michelle, I have acknowledged. I'm sorry I was not there already.
Yeah.
I'm very sorry.
Yes, okay, but we have representatives of our project in this conference, so of course we can. I think we learned a lot through this conference, which we can actually use within our project and improve things a lot. Thank you. So we. Thank you. So we have two more presentations, one remote and one physical. Let's go to the remote one first, according to the schedule. So Konstantinos Tsutas. Konstantinos?
Can you hear me?
Yes, we can hear you.
Okay, I have a little feedback from you there when you. Can you see it?
Yes, we can see it.
Okay. I'm Konstantinos Tsutas.
Excuse me, you are showing the presenter view. Maybe it's not presentation.
Do you have two screens?
It's the same thing?
No, switch to single screen or something.
Okay, start the presentation, and on top left you can switch the views. Go in PowerPoint. Start the presentation with PowerPoint. No, it's in editor mode. Start the diaporama. Okay. No, on top left, stay like this. Display settings. Click. Swap. Yes. Yeah, that's it.
Okay, so we you have any questions, I will be glad.
Thank you, Costa. We have one question from Michelle.
Yes. How did you test GT, for example? Because as it's using WebRTC, if you are in the same room, it will be instantaneous or nearly instantaneous. But if you are from different long distance, it depends if it uses a server in the middle or if you manage to get a direct peer-to-peer connection, because the WebRTC protocol is doing lots of things behind the scenes. If you open a VPN, you'll get other results and so on.
Yeah, it's complicated. I assume that according to the documentation, when I use two peers, I have a peer-to-peer. So when I did calculations in the lab, I think my packets didn't go out, didn't go outside, didn't go to the server in Crete. I had the path from the one computer to the other, but I cannot confirm that. In the case of more than two users, you don't have a peer-to-peer. You have all the packets going to the server.
I think you have to configure peer-to-peer to get peer-to-peer in Jitsi. And he was using the server in Crete.
Okay. I've been working a lot with WebRTC, so you can have a mesh even with 4 users, but depending on your router or your firewall, it does the deep packet inspection. Sometimes it doesn't let you open a peer-to-peer connection, even on a local network. If you go with the Wi-Fi of the university, you cannot. And then in that case, it uses a turn server. That means in a man-in-the-middle server. And in that case, the latency will be doubled at least. So this is why I say with these peer-to-peer tools, you must be very careful when you say they are faster, because it really depends on the way you open the connection. That was just my 2 cents.
I think Jitsi was used with our server in Crete, no?
Yeah.
So it was the signal was going Athens to Crete and then back. We have our own server. Okay, this is interesting. I would like to talk about it later. So thank you, Costa. We're running out of time.
I have one more quick comment if you have a chance. That was a
Okay,
really
yes.
cool presentation. I'm wondering, so it does seem like from a latency perspective, part of it may depend on the server distance from where you are. So if you had just a computer in your lab running your custom server, I'm wondering, I know you didn't do this experiment, but it might be cool to look into. You have your own server, I don't know, right next to your office. Would that give you comparable results to Sonobus?
Okay. I have a computer here with Zitzi, which runs Zitzi. Here, it's next to me. And the delay is big.
I mean like the server, because for Jitsi, it's still being sent to Crete. But if you have another server that's running, that's doing the relay, I don't know, maybe. I'm also not too familiar with servers, so this could be a bad question.
I'm going to say about it. Okay. But the machine I have here gives me over 100 milliseconds to hear my sounds. To go to the server and come back.
You want to say something?
But you're still sending it to Crete, right? For Jitsi, because since it's based in Crete, it has to go to Crete, come back to where you are.
I think the 100 milliseconds is without the.
Oh, without the server.
Without Crete.
Oh, so Jitsi is like, okay.
Also a second server, second Zitzi server.
Oh, okay, got it.
Okay, well, thank you, Costa. We need to go to the last presentation for this workshop, which is a physical presentation. The presenter is here, so it's Konstantinos.
Hello, I'm Konstantinos, and I'm really glad to be here and to share and listen all of these interesting ideas with you. It's really inspiring for me because I'm in the start of my PhD. So me and my colleagues, Máximos Kayakatsos, Konstantinos Giannos, and Emilios Kabouropoulos, I'm Konstantinos Velenis, we created an application which objective is to facilitate the exploration of jazz standards for improvisation training with web visualization. So you can see the application through this QR code, and now I'm going to do a demonstration just to show you what it does, and then I will present you the challenges of what we have encountered. Oh, no, wait. There is Firefox here. So this is the UI. On the top left of your screen, you can see points, each one of them representing one jazz standard song. It's 1065 jazz standards. As you can see, with the tooltip, you can find the name, style, and tonality of each song if you hover the points. Their distribution in space is based on their harmonic similarity. I will explain it a little bit briefly afterwards, but in generally, those points that are far away don't share so many harmonic similarities, characteristics, and closer points are more close harmonically. So on the right side of our screen, we see all the details of the song. If I select one song from my graph, I'm rendered there. And also we have our player here, which what it does is play the song and simultaneously give us the current chord and the 4 following to come. So it's a player that you play along with whatever song you choose from the graph. Okay, let's hear. No sound. Okay, we have a little bit of a delay. Okay, so another functionality that we have in our UI, it's basically a functionality that we took from the Genius Jam track application that Chrysula told you before. It's an application where you play along with your iOS various jazz standard songs. So we took that feature and we added to our application. I will explain later how. So here we have different complexities, harmonic complexity and rhythmic complexity. So you can alter the level of difficulty of your play along song. So let's maximize those values to see clearly what happens. So more complex rhythmic patterns and also more sophisticated chords. Moving on to the right, we have here a search field that I can search a song. Let's say take 5. Okay, it enlarges my point here to see where is it. And also we have another search field where we can compare to basically 2 songs. So let's say segment. Okay, that's another use case scenario for a professor or a student that they want to explore where their songs of interest are in this space of harmonic similarity. So last but not least, we have that slide over here. But what it does, it basically clusters our tracks into different teams. These teams share also similarities in the harmonic characteristic similarities. So we can team up our graph up to 20 different teams. So here is another example. Another use case scenario educational is that maybe a teacher wants to start from the blue area, and then for 1 month or whatever time he wants, he can teach from that blue area that share harmonic characteristics, and then jump up to the next closest area, like the green one, let's say. Okay, so also here we have divided our data into two different graphs. Here are all the songs with their original tonalities. And here are all the songs with the tonalities of the songs neutralized. Both of them are useful for various reasons in different cases. So let's jump up to what happens? Our presentation and see how we figure out to build that application. So for start, I want to speak about the similarity and the distribution of the data in our graph. So the way we did it, it's by using a LSTM neural network algorithm, and by creating also strings like that one, but contains information, chord information, so harmony information for each one of our track. Also, it contains style, tempo, and tonality. So we trained this LSTM neural network algorithm, and after that, after the training, after we feed it all our strings, we redid it, and it came up with a matrix. But I will explain it briefly, with 256 dimension matrix. So after that, we did a dimensionality reduction to all this data that they refer to the similarities of the strings, because that algorithm goes autoregressively character by character and do the comparison, likewise, comparison of these strings. So after that, we do a dimensionality reduction with a Tisney algorithm, and finally, we use a k-means algorithm, clustering algorithm, to do the clustering that you saw with the colors. So we use 20 times this algorithm to produce 20 teams of our graph. And lastly, we used the Plotly JS library, which is an open source library with many built-in features like zoom in, zoom out, moving the graph left different directions. And we added like alteration of color and enlargement of the points, as you saw before. So that's how it works. The position of the songs in space. That's the methodology. And the second big part of our application, of our development, was how to implement the player of the application, because we wanted simultaneously play the MIDI and also show the chords, the current chords and the following to come. So to achieve that, we took the output of the Genius Jam Track application, and we created a protocol in a CSV protocol. That it looks like that. So firstly, we iterate all the table, find all the chords, all the cells with the identified chord. We store all the chords in a list, and then afterwards we reiterate all the table, and let's see what happens line by line and column by column. It sees here is the code, but I will explain it briefly. So it sees pre-count. Pre-count is the clicking before the song starts. So let's move on to bar 0. That's the first bar. there is a style swing because from bar to bar the style can change. There is our rhythm, our tonality, and our tempo. Next on, the code finds chord, and then it sends to our list to show the first chord and the four to come from our list. And then it goes to bass. From there, bass, drums, and piano are all instruments, so it sends the MIDI value, which is 36 to the bass, the onset value, which is 0, the duration value, and also the velocity value. To the MIDI player, it's a Surikov ready-made MIDI player, and it's available online. I can show you his GitHub. So it's another, yes, it's a ready-made MIDI player. What we have, no, not MIDI player, sound font, basically player. And then finally, to summarize all of the work, I'm trying to be a little bit hurry. Yeah, sorry. We did the evaluation, an alpha stage evaluation of our application based on 10 heuristic criteria from Nielsen. Made it more simplistic and with warnings and tips for the users. And okay. Thank you for your attention. And this is our GitHub link if you want to see our code. And
Okay, great. Thank you. Quickly, yeah, one fast question. Is there somebody else? Yeah, okay, thank you.
So I was wondering really fast what the LSTM is doing in the process. 'Cause
Sorry,
are you
sorry,
doing any
I
inference?
cannot hear.
or-
What's the LSTM?
Yeah, what is it doing in the process?
What is the?
What is it doing? What is it contributing?
I cannot hear. Sorry.
Oh, sorry.
What does it contribute to?
To the process. It gives us the 3D space of all the 1065 just standards of the similarity in 3D space, in harmonic similarity.
Yeah, okay.
We use it to distribute all the data based on the harmonic metrics on our 3D space. We will discuss them if you want a little bit, yes,
We
later.
can discuss it
More, yeah.
individually. So thank you everybody for participating in this workshop. I hope you find the presentations interesting and inspiring. And I hope we didn't take much more time than we should, Michel.
Thank you, Chrysola. Anyway, with a hybrid conference, we always have some technical issues and microphones are not working for the remote and so on. So it's not your fault. It's just complicated. Ariane, so we switch the best paper award and the final thoughts of the conference after Ariane because she will play with musicians and we must free them earlier because they have a concert and they need to set up. I will get people from the Glycol workshop and bring them here. Install yourself. Yeah, okay. So start setting things up. I'm going to get those.
Hello, hello. Yeah.
Okay, it's good.
It's all right. Let me play the play sound to see if the volumes are all right. No, so not coming. Google Chrome. Yes. Hello.
Okay.
Hello, 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 hello. I'm gonna put a very loud sound, okay? So just test. Hello. It's all right for you? The volume is louder. Yeah. Let me check. Okay. Now it's better? Better? Well, how do you feel that? Hello? It's all right? Oh, it's too loud. It's still too loud, no? It's good? The microphone. Yeah, hello? Hello? What?
The sound is a little bit distorted. I don't know if that was
Maybe
your wish.
that might be look back out. No, not here. Maybe. Try again. Try again. Hello? Hello? It's better? Maybe it's that. Can you put everything flat for me?
It's right.
Okay. Hello? 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 Hello?
So on the microphone, your gain is too heavy.
Okay. Hello? Hello? No, it's not.
What?
No, I don't have gain actually. Hello?
In the preference system on your.
I'm using
laptop.
look back audio. Hello? Hello? Hello?
It's good.
Okay. So don't you maybe no, let's, because there's so many people out, because we could even do the performance before the talking, but we could do the performance before the talk, but I think there's so many people out, so I'm gonna talk and then we do the performance.
Par contre,
Huh?
for the film.
I need, yes, I actually need the cable.
C'est
The HDMI.
Michel stream the film or you?
No, they're streaming the film, but I need
You okay
for the slideshow. Thanks.
You have an
Yes.
adaptation.
Let's hope it works. Otherwise, I will share with you on Google Drive. Where is my? Okay. Okay. So I'm gonna record. Okay. I think when Michelle's back, we start. I can do a very short talk and then we play. Oh, look what's happening here. Yeah, it's not PowerPoint, so it might work.
Do you need the sound from the computer, maybe?
No, I don't have it.
No, I have it already.
You want to control your channel or not?
What's my channel?
Channel is 910. Yeah.
Okay, so is everything flat? Is everything flat?
It's here on the.
Maybe we reduce the gain and I can enhance the volume here.
Okay.
Let's just. Let's see. Reduce a bit. Hello, hello, hello.
You can,
Hello.
yeah.
Yeah, I think that now it's. I'm reduce a bit more.
A bit more.
Hello, hello.
A bit more gain is possible.
Hello. No, 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 don't need it. No. Let me try to put the sound together to see if they are. Because I messed up some stuff. Yeah, so the sound. No, I need to reduce the microphone.
So your microphone.
I need to reduce here. Hello, 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 hello. Let's see. Okay.
And the film, where is the film?
The film is on that computer.
The computer, Michel.
Yeah,
Computer?
yeah, I think
Okay.
so.
And Michel
Maybe
is
we
not
bring here. So after I talk the presentation, just change the cable.
Mais Michel, il a le film sur son ordinateur. Tu as le film sur ton ordinateur. Le film de Méliès.
Alors lequel?
Le premier, le voyage d'un voyage.
Le Blu-ray One de Man on the Moon?
I put yes.
Ouais, oui, c'est beau. Il est beau.
Bah, le câble de Laurent, c'est avec elle, il y a un deuxième.
Le E, il est plus lent.
Ouais, ok. On n'a jamais eu. Porque tem a ver o computador, que tem uma coisa para mostrar.
O meu é slideshow. A hora que eu acabar, a gente troca o cabo e vocês passam o filme. Só para mim.
Porque o filme é durante o negócio.
É com a performance.
It's the Man on the Moon Blu-ray version color without sound.
Yeah, without sound. Yeah.
Okay, so
The colored version.
the color version. So you tell me you and I read it.
Okay, just when I finish.
Yeah, okay, yeah, explain.
Yes. Okay. Thank you. I don't have this. Oh my god. Why it's not working? Okay. Oh wait, it's not this. Okay, so you're recording everything, huh? Are you recording everything for the conference? Because my recorder just not like this. Just gonna do like just for keeping track of everything. My microphone is not working. Okay, are you guys ready to take some pictures? Thank you. Hello. I will just turn on a bit louder just while I talk and then switch back here. From here.
Okay.
Hello, good evening. Good afternoon, actually. I'm Mariane Stolfi. Some of you may already know me. Some from past conferences. Some we met here a few days ago. I am professor of arts and communication on the Federal University of South of Bahia. And I'm doing like just a small talk to let you know how I end up here in the end. And then after we will do a performance with these super nice musicians using my web audio tool. So yeah, so that's basically how it started. I got very privileged to be at this space. This is the Architecture University on the University of São Paulo. This is considered the most beautiful architecture building in the world. For some architects, it's a very nice brutalist architect from Brazil, Vila Nova Artigas. And as you see, like this building is amazing. It's enormous. It has like all acoustic possibilities inside. We had parties, we had meetings, gatherings, and we had lots of resources as well for woodworking, for printed press and everything. So like when I went there, we started to do students union or something like that. We had this, don't let the university disturb your studies, because we had so much things to do that sometimes we had to do by ourselves. And it was there where I started first to get involved with music. First I was like being DJ because I had to earn money from throwing parties, but also doing manifestations, political acts, like this one we had this maracatu group. It's kind of a traditional Brazilian rhythm that we play in the streets, walking around. But we had this political standpoint, so we had sometimes went to destroy walls or something like that, but also every kind of manifestation we had. So that's actually where I started to playing music. But I also, at the same time, started to do working with this baby, buzz machines. This was kind of obscure software from the 90s, but it has like these blocks. It was a free-to-use software with loads and loads of plugins. It had the craziest synthesizers inside, like a modular approach that like Ableton had copy from that, these modules. So we had patterns, we put on time, and had this all the DSP processor chain. And I started like on both sides. I was doing the maracatu and I was doing these things. They were not really connected, but we also doing like free improvisations and jam sessions at the lunchtime. And then I started to record this stuff at some point. So I had this, I started to learn HTML at some point and working with web programming. And I had this crazy domain, insane plan that I rented on DreamHost in 2005 that I still have until now. It allowed me to have infinite space, infinite domains, and infinite like subdomains and everything. So I still host lots of sites on this server, but I started this to be like a record label, experimental record label. So I was recording lots of stuff, putting this on this page. First, I was like actually writing HTML at this time. So this is my first project. I was calling Proto Musica because I was not considering myself like a proper musician at the time. But I may show you a bit. This is This is from 2006, 2005. I may show you a bit. Yeah, so this is Fine Thanks Now. If you go there, it still works. So at in the start, I was doing like these pages to recording like people that I was around, this ecosystem, very creative ecosystem. And I had this like, this was I think, how do you call this element? I forgot. I think this is this is basically my first album, say like that. But at some point, the player is not really working now anymore, but it's okay. But at some point, I started to have too many things to edit and to produce, and I decided to go to a more brutalist approach. So that's how is the Find Thanks repository now. So if you go to findthanks.com, you have records here, and then this is the best website. And I still use that for putting stuff. So here there are from 2005 to from 2010, but if you go there, less modified stuff, you can find that I just put something last week this is, if you might interested to hear something, this set here is the last thing I put on the website. It's going to be a radio art project to be presented on Switzerland. And it's just like 1 hour of compilation of my work. So that's all the things like from buzz machines to the newest one with Play Sound and everything. And now with Mini Moog as well, something that I play now. Okay, so let's go back to the presentation. Yeah, so this is the Find Thanks. And actually at some point, it got like 2,000 views a day. Like people were really like listening to that. Now I don't even check the statistics, but something like left behind. At some point, I got in contact with the Pure Data community. So that was something that really opened my mind. It was a PDCon in 2009 in Brazil. So I had the opportunity to have the workshop with Miller Puckett in the place that I went to study lots of years after. So this is my first project. I couldn't find like a nice video, but oh, sorry. This is super small here. I can see the proper, yeah, here. So this was something we made to play in three people. It was the first time I actually played in a museum, the Museum of Image and Sound. It was a kind of live cinema event. We had, I did a patch on Pure Data for that. The guy was playing with the buzz machines in another computer. And the other guy was selecting videos. So I had these video selections inside shapes, and the shapes I got the audio input from buzz machines to Pure Data to get processing of the size of the image. So we have a filter for the low and the high, and did like some cool graphics with a gem. And then I started to also do some noise patch for Pure Data. This is my, it's like was years of working on this patch. This has the different modules like that. So this is a wave shapers. This is something nice. It's a kind of interval stepper. So if you click like this, you go like 3 semitones or 12 semitones, and you can come back like 12 semitones. You can go up and down with this noise, with these wave shapers here. So we had like 3 synthesizers. This one something that you like go with the mouse, and you had like harmonic, and had some samplers. This was like a sequencer, very beautiful patch. Like I like to do like handcrafting stuff, and like this is a small part of the I think it's the sampler, yeah. Yeah, and then at some point I got invited to help with Daniel Scandurra and Gabriel Kerhardt to do an homage to Gilberto Gil. So I think most of you may know Gilberto Gil because it's like one of the most famous singer in Brazil. He's like one of the heads of the Tropicalia movement. And he was doing like 70 years old birthday. And they asked me, okay, let's do something with Pure Data, something interactive for him. But it was in 2014. and they just got released the HTML5. And I was like, actually, I didn't talk much about that, but I work a lot with web dev and digital culture and lots of different projects. Maybe after I can give you my website if you are interested. I'm gonna show you this because this is still online. So we had this HTML5 coming up. Okay, I can't even see the mouse, it's very little here. So I propose instead of doing something in pure data, we built something in HTML5. So I had this, this is an online version. It doesn't have all the videos that was in the real version. And it was presented as an installation. So we had this totem with a touch screen. And here we had 6, we call hexagram because it's like an hexagram for the maybe.
O desobjeto, o Deus objeto.
Retrato de lambe-lambe da mesma.
Fazer amor.
Que trânsito horrível, meu
Ai,
Deus.
de vez em quando me sentia longe daqui.
Ainda canto o ídolo ainda canto o ídolo de durada saudade.
Vamos ao show que tá na hora. E o disco que eu prometi ficar pro São João.
Lembra uns doce verde, um sorvete verde. A cabra, o bode.
So this, we took, like, we take all Gilberto Gil's songs, all of his albums,
E os homens
and
tudo
look for
encorado,
significant parts
vaqueiros,
that could work
os
as
boiadeiros,
unity, like
e os violeiros,
a sound
a
object.
rapadura,
And everything's, they're like 2 gigabytes of
os sacos de
MP3
farinha na
samples on this.
feira,
So 280 sound samples. The hardest part of coding that was actually making this infinite loop, because this one can be dragged like both on horizontal and vertical infinite one. So it's like so for these sound samples, we got
meu São João.
like they are in separate places. So I just load ones and had infinite GIFs that been growing. At some point it crashed, so the guy went and he started the browser, so it's all right. And this one is the only one that is not infinite.
Sertão é duro, mas é
longer
bom.
sounds. So this was like the first job that I really like gave me a bit of recognition as sound artist and stuff. It was in 4 of the most important museums in Brazil. And I had finished my mastering. My master thesis was on web design. So I was studying code, the relationship between code and interface. But then I say, okay, once I had that, I can try to go to the music because that's what I wanted. So I tried like for a bit, but in the end I got accepted that. So I started to do like proper music. So because now, like until now, I was doing music. Then I started to do pieces. So this is the first, like my first composition on electroacoustics called Bandas Críticas. So this is basically the score. It's for 3 players. We have 48 oscillators, one of each critical band center, and one in the limits. So they were started together. It was controlled by pure data. It started together, and then he had some freedom to do some stuff around. And then in the end, he was just degrading the waves. So we got like silence. Just this was presented in some concerts, and I started to be like my advisor started to taking account like what I was doing. But at the same time, I was doing this as well. So we like playing carnival, percussion on carnival on the streets. This is Block OK. It's a kind of a carnival block, but we have open microphones. So we are playing battery, and that's a lead singer, like some lead singers, but we had also people join to play popular karaoke songs in Brazil. So at some point we had like 6,000 people on the street. Yeah, and also I got in contact with people from the computer science. We had this new song research group that is quite famous and recognized. Fernando Iazeta was my advisor. I don't know if you know him, but it's quite important there on sonology. It's not like real music, but sound studies, like something. And I went in partnership with a guy from computer music to do this open band project. So this is my first interactive participatory performance proposal. So basically, I'm gonna show you the teaser. This is a teaser, very short one. I started to send some. What happened? Yeah. So this is the volume here. Okay. Yeah. So this is a teaser we sent to some conference. I think maybe I will go a bit further. We had this chat interface to the cell phone and play together, so that large audience play together. Very chaotic sound. Then at some point I changed the sound. And I started to present this as a first conference in several festivals. Still works, it's still online, so if you want to try out the website, they are still actually doing performances of that every time people enter in the computer and mathematics institute. So they do for the new ones to say, oh, look what you can do, so nice stuff. And I present this a lot in a lot of places. At some point I got the scholarship to go to the C4DM at Queen Mary University of London to study. And the problem with open band was just like a performance. It was not something like I could use that as an instrument. And I was already there in the University of São Paulo. I was really involved with free improvisation, and Orquestra Errantes is like an ensemble with traditional instruments mixed up with everything. And I never have figured how to use in a good way even pure data, or not like any DAW with the computer together with the musicians in the free improvisation context. So I started to develop this play sound. I get help from Alessia Milo, from Michael Ciano, Matteo Bartet. Even Ana Xambol was one of the users that tested the system. And this was super nice. This is something I'm gonna use today. I presented in a few like the past conferences, both of performances or just research papers. I got this like agile method, so I like doing something and then publishing and doing something then publishing, because I think in the end when I was there I had like 8 papers or something about this. Sorry, yeah, just finishing. And this basically it grabs sounds from freesound.org I'm just a few minutes. And I have this search as spectrogram, so I can have collections of sound. I'm gonna use this to perform. And after that, I went to the Federal University of South Bahia. Maybe we could go there with the Web Audio Conference. We have at some point. This is where I'm living now, basically. We don't have anything, but we have nice students. And then I was doing this Reverbera project. That's what I'm gonna present. Because we don't have this in there, we don't have any experimental music scene. So we have to build it up. So train people, start to train people to practice and everything. So what we're gonna do now is the same thing like I did with my students. We're gonna play Georges Méliès movie and do live soundtracks. I'm gonna play sound, but also together with the musicians. So that's the point, the main idea. I'm gonna change this, change the HDMI so I don't get glitchy. Yeah, but basically while they are setting up, I can explain a bit more of play sound. It's basically a looper. You can put many loops together and, okay. One second. Yeah, and it's open to use. You can try it out after. Maybe in the jam sessions, if someone wanna use my computer, you can do that. Yeah, maybe it's nice if you can. Okay, so that's it. Great, a good movie. How to say? You say merda in Portuguese.
Les lumières. Oh,
Thank you very much. Thank you. So just remember, after we have the jam session, so I still have to set it all up after the concert. Merci, merci, merci.
Thank you very much, Ariane and the musicians, for this wonderful improvisation. So our musician friends are leaving. They are going to set up for the concert. And now we will quickly give the best paper award and say some final words about the conference before the concert and the cocktail and the jam session. So I hope that you are not going to leave because we need people for enjoying the party. So Norbert, do you have the paper? No? Marie-Claire, you got the paper? Okay. So can somebody put the camera on me because and stream that, please? So I asked yesterday or the day before yesterday Norbert to form a best paper committee. And I don't know, but yesterday they were discussing a lot and they took something like 12 hours for deciding or maybe more. Yeah, it was a very hard discussion. So finally, the best paper award. I don't have my glasses. Yes, I got my glasses. Is given to Ian Klester and Jason Freeman from the Georgia Institute of Technology for their paper called Alternator, a general purpose generative music player. Can you zoom in a little bit? And maybe, Norbert, do you want to say a few words about what quality you like most in this paper? Or?
What we really appreciated that the paper has clearly a technical side to it, but also a very musical side, and really is one embodiment and a good embodiment of this conference, offering perspectives to really new things you can do in terms of music using web technology.
Thank you very much. So just a few words. It was a real pleasure to have you here. The journey is not finished. And I went on a wild ride, you know, with sometimes my heart beating very fast when we had technical problems and delays and everything. But this is, I think, going with all hybrid conferences. So I hope you understood that everything couldn't be perfect. We had good food, good weather, good people, good music, and it's not finished. So please thanks all the organizers, all the people with yellow, orange jackets. And also, you can say kind words to the people that stayed at the registration desk because they organized all the food things, all the restaurant for yesterday. I was as surprised as you by the quality of the banquet on the beach. And Frédéric, can you? Yeah, Frédéric was in charge of the staff, and Frédéric was a referee at the Soccer World Cup 2002 in Korea and Japan, right? Yeah, so we at least needed such a pedigree for managing the staff here. Yes. So please keep enjoying the rest of the evening. And now let's have a good time. So normally there is a small break. Then we go to the second floor at another amphitheater that has been especially set up for 2 concerts. So it's a bit of a surprise. I don't know exactly what it will look like and sound like. So let's go there.